എത്ര പാർട്ടിസിപ്പൻസ് ഉണ്ട്?
Sir, around 40-50 participants are uള്ളത്.
Oh, very good.
So join ചെയ്തിട്ടില്ല, join ചെയ്യാൻ പറയാം.
കുഴപ്പമില്ല. M.Tech സ്റ്റുഡൻസ് ഉണ്ട് അല്ലേ?
M.Tech സ്റ്റുഡൻസ് 24 പേരുണ്ട്. പിന്നെ പല സ്ഥലത്തു നിന്നായിട്ട്, പല സ്റ്റേറ്റ്സ് നിന്നായിട്ടുള്ള സയന്റിസ്റ്റ്, ടീച്ചേഴ്സ്, എഞ്ചിനീയറിംഗ് കോളേജ് ടീച്ചേഴ്സ്.
ഇവിടെ ബാക്ക്ഗ്രൗണ്ട് നോയ്സ് എന്തെങ്കിലും ഉണ്ടോ? മീൻസ് ഈ റോഡിൽ വണ്ടികൾ പോണതും അങ്ങനത്തെ വല്ല?
ഇല്ല സർ. സാർ ഇപ്പൊ ഇവിടെ പ്രേയർ ഉണ്ട്, പ്രേയർ അവിടെയാണോ സാർ പറയണേ?
അതെ, അതായത് എന്റെ സൗണ്ട് സംസാരിക്കുമ്പോ ബാക്ക്ഗ്രൗണ്ട് വണ്ടികളുടെ വല്ല അധികം ഡിസ്റ്റർബൻസ് തോന്നുന്നുണ്ടോ?
ഇല്ല, പ്രശ്നമില്ല. അവിടെ തന്നെ റോഡാണോ?
ഉണ്ടെങ്കിൽ വിൻഡോ അടിച്ച് ലൈറ്റ് ഓൺ ചെയ്യണം.
ടൈമായി. പാർട്ടിസിപ്പൻസ് 18 പേരായിട്ടുള്ളൂ. 2 മിനിറ്റ് കൂടി വെയിറ്റ് ചെയ്യാലേ സാർ?
കുഴപ്പമില്ല, അതിനൊന്നുമില്ല. ഞാനൊന്നും ലീവാ വീട്ടിൽ, അതുകൊണ്ട് വേറെ തിരക്കില്ല. കോളേജിലാകുമ്പോ ഭയങ്കര തിരക്കാവും.
ഫുൾ ഫ്രീ ആന്നൊക്കെ അല്ലേ? റെസ്പോൺസിബിലിറ്റി ഒക്കെ ഉണ്ടാവില്ലേ സാറിന് വേറെ എക്സ്ട്രാ?
അതെ, ഫോണൊക്കെ കോളേജിലാകുമ്പോ ഇടയ്ക്കിടയ്ക്ക് ആൾക്കാർ വന്നുകൊണ്ടിരിക്കും. ഇപ്പൊ ശല്യമില്ല.
Good morning, sir.
Morning.
So we'll start. A warm, very good morning to one and all. I am Ambuli, Assistant Professor, Department of Civil Engineering with the Academy of Science and Technology, Thrissur. Let me welcome you all to the final day of AICTE-funded Adult Faculty Program on recent trends in earthquake engineering. Today, we will be having two sessions. The first session will be handled by Dr. Said Jalaluddin Shah, Professor and Head, Department of Civil Engineering, MES College of Engineering, Tripura, from 9 a.m. to 11 a.m. on the topic Earthquake-Resistant Design of Foundations. And the second session will be led by Mr. Anil Kumar PS, Associate Professor, GEC Thrissur, on the topic Cyclic Softening and Failures in Sensitive Soils from 11:15 to 1:15 p.m. Today, we will be having the valedictory function and feedback session at 2 p.m. in the afternoon. So the participants can share your feedback. We would love to hear from you all. So now let me welcome Dr. Abhilasha PS, Coordinator of the Faculty Development Program, to introduce the speaker of the first session. Ma'am, please.
Thank you, Amelie. Good morning, sir, and dear participants. Let me share my screen. Sir, can you stop sharing your screen? Is the screen visible?
No, ma'am. Visible alla.
No.
ഒന്ന് സ്റ്റോപ്പ് ചെയ്തിട്ട് ഒന്ന് ഷെയർ.
Pardon?
സ്റ്റോപ്പ് ചെയ്തിട്ട് ഒന്നുകൂടി ഷെയർ ചെയ്യും.
Now it's visible, I think. Right?
Now visible, now visible.
Okay, thank you. It's not on the slide show. But it's visible, right? So I think I shall continue like this. So once again, welcome all to our fifth day of online Untitled FDP on recent advances in earthquake engineering. So for our today's first session, we are having Dr. Said Jalaluddin Shah, Professor and Head of Department of Civil Engineering, MES College of Engineering, Tripura. And his topic is Earthquake-Resistant Design of Foundations. So about the speaker, his qualification is in 2006, he completed his PhD in Civil Engineering from IIT Madras with specialization in Geotechnical Engineering, and in 2000, ME Honors in Civil Engineering with specialization in Transportation Engineering from University of Roorkee, and BTech in Civil Engineering from Government Engineering College, and also he did Bachelor of General Law in 2012. He has more than 25 publications and attended many conferences. And regarding his awards and achievements, he has received Indian Geotechnical Society's IGS Professor Leonard Svenel Award for the best PhD thesis produced in India in the field of geotechnical engineering. During the year 2005 and 2006, and in 1990, he got Rashtrapati Scout Award from President of India, and he's a reviewer of NPTEL web course titled E-Book on Concepts and Techniques in Geotechnical and Foundation Engineering posted on the NPTEL website. He guided Mr. M. Roshan Khan for his MTech Geotechnical Engineering, and he received the IGS AI SAT Award for the Best MTech Thesis from Kerala in 2013. And he guided BTech students whose project work regarding rehabilitation of concrete road in Thrissur received the Best Project Award and was published in the Madhubhumi newspaper. And lots of professional memberships he has got, that is Indian Geotechnical Society, International Society for Soil Mechanics and Geotechnical Engineering, Indian Roads Congress, Indian Water Resource Society, Indian Society for Earthquake Engineering, Indian Society for Rock Mechanics and Tunneling Technology, International Society for Rock Mechanics, and Institution of Engineers, India. And he's consultant for soil investigation, structural distress, and forensic investigations and studies. So in each subdivisions are for soil investigation, single or double storied houses, multi-story structures, bridges, highways, and other infrastructure projects. And related with structural distress, they are repair and rehabilitation guidance provided for buildings, roads, and other infrastructure projects, and also soil testing and foundation recommendation services provided. And in the case of forensic investigations and studies, analysis of failures and proposal for rectifications are provided for buildings, roads, retaining walls, and other infrastructure projects. So we are having such a vibrant personality with us to deliver our first session of last day of the FDP. So I warm welcome you, sir, to the platform. Welcome, sir.
Thank you, Abhilasha. Thank you for the really kind words. I am really thankful to the management, the principal of
Sir, you're muted, sir. When you started your slide, you are muted, sir. Sir?
yes.
Yes. But still, I think they're not able to hear you, sir.
Yeah. So thank you, Dr. Abhilasha. I'd also like to thank the management and principal of Vidya Academy of Science and Technology, the head of Civil Engineering Department, Dr. Justin Jose, who also is my senior in BTech. So it's a pleasure to be with you and to deliver a talk. In fact, when I received a call from Dr. Abhilasha, I knew that probably Justin is behind this, so I could not say no, although I'm a little busy nowadays. So giving a talk and preparing slides, all is a big, it's a big time-taking thing. Anyhow, it's a good occasion to meet some interested people in this field of earthquake engineering. In fact, this topic is actually a one-semester course during MTech. During my MTech, I had this course, and later on in practice, I'm involved with the soil investigation and foundation recommendation. So nowadays, with this, the government stipulating that we are in the zone 3, and we need to take steps to ensure that our foundations are safe. So how do we do that? So that is some small thing that we need to do, small things. If we are careful with many of these things, we'll be able to have some control over the disasters which are going to take place. So what sort of things we can do, to what extent we can do. I try to cover things as much as possible, but the question is, I don't intend to go into the mathematical part of it because that is all very involved. I'll try to give you some concepts regarding how to deal with a foundation design if you are going to have an earthquake. So with that intention, I have just organized the contents in 5 parts. The first, the seismic hazards, what happens during an earthquake, then sites assessment and foundation selection, then the normal foundation design, then going to the seismic design of foundation, which is our main topic. But some some background into the other things I thought would be good enough to have a better understanding of that. And then finally is the soil improvement, which if we have time, we'll cover that, or otherwise, it is just for you to know that we do need to have some soil improvement in order to reduce the possible the failures which can occur. So we'll just start with the seismic hazards. You know that when an earthquake occurs, we have a lot of ground shaking. Then the structural hazards, liquefaction, and so on. We'll quickly see one by one. The ground shaking, you know that whenever an earthquake occurs, we know that an earthquake has occurred when there is shaking. And when this shaking occurs, you can have vertical shaking and you can have horizontal shaking. And out of these two types of shaking, the vertical shaking is more common if you are near to the epicenter, and the horizontal shaking will happen if you are even at a far away distance from where the epicenter of earthquake is. So you have to take, in other words, the vertical acceleration and the horizontal accelerations into account when you are going to do any sort of a study. So all these things you need the transducers, you need pickups, acceleration pickups, and so many instruments are required. So using those, we will be able to collect all this information. Now, I'm not going to give you the you just have a small feel of what this shaking occurs when you know if you're traveling on the road or something. Let's see. So you can see the shaking. All of a sudden, the entire thing is shaking. So this is not something which will affect only human beings, but it is also going to affect the buildings and the foundation of buildings along with that. So yeah, so coming to the next thing, the structural hazards, you know that a lot of damage will occur. The masonry will have some problem, the concrete and all these things will get damaged. Inside houses, you'll have brick and parapets and shelves, etc. falling. So you'll have a lot of structural hazards, and loads associated that also will be coming. You can see this building which is just shaking, and you can see here how this, see this I think, yeah. Now you can see this, how it has fallen down. See, this building has fallen down because you know that the connection between the bottom of this column and the pedestal, you know that there it was not able to bear the excess stress. What the foundation did or did not do, that's a secondary thing. But the connection, if the connection between the two was strong enough, then probably this thing could have been avoided. And then one of the other commonly found problems in earthquake places, liquefaction. Now, liquefaction, in simple words, what happens is that the soil, you know, it's a solid, but it becomes like a liquid. It loses its entire strength and it starts behaving like a liquid. And for your information, liquefaction happens when you have silty and sandy soils, loose sands and silts. These are the things which cause liquefaction, and in this your entire building can just sink inside, it can fall down, and also another important thing, like when we do the soil investigation, if your standard penetration test N value is say less than 12 or 10 or less than that, and if the soil is silty or sandy, as well as you have a high water table, then the possibility of liquefaction is there. Your vehicle will simply sink into the ground. Then landslides are another big hazard. When you have a landslide, simply you have this soil flowing from one side, moving from the hilltop to the other side. So in that sort of a case, what do we do? If you have a shallow foundation in that sort of a place, nothing can be done. Your entire foundation house, everything will go and just slide. So shallow foundation is not going to help you out in case you are going to construct a house in a landslide prone area. Now coming to slope stability, this is also another big problem during earthquakes. Not only during earthquakes, during rainy season also we have this. So if you have a rainy season plus if you have an earthquake, then the failure surface will occur. And what do we do in this case? If this part failure surface is going to, along this failure surface, if it is going to fail, what can you do? In order to prevent that, you should have some kind of foundation which goes inside this, or some kind of reinforcement technique which will allow which will stop this failure surface from developing and going. So that is the point of view that we have to look at this. Then you can do this slope stability analysis for that. The same thing you can do it in the dynamic thing. You can do a pseudo-static analysis. Pseudo-static means you probably may have got some idea by now. So it is, you know, like we have this G, like the force is equal to mass into acceleration. So the force, in other words, if the weight of a body, that will be the mass into G. Now, instead of mass into G, if you have some another acceleration acting on that, then the additional force due to that particular acceleration is going to come. So that M into this A plus M into G. So that those two, if you add, it will give you how much more force is going to act. So it can be in the horizontal way, it can be in the vertical way. So that concept you can use to do a pseudostatic analysis. Then we can have retaining wall failures. This is also one big issue that we fail. Even if you don't have an earthquake, this is one big problem. Very commonly, we find during the 2018 earthquakes also in many places, in the flood also, we had this retaining wall failures in many places. So that is one big problem to take care of. Types of retaining wall failures, anything can happen during earthquake. Then lifeline hazards, you can have a lot of pipelines, they can get destroyed, things like that. Then tsunami, you all know, I think it is quite still many of you might be remembering the tsunami. So this tsunami also causes its own problems. So now these are the commonly found problems during an earthquake. Now, the second part is you always have to do a site assessment and foundation selection. So all the foundation selection for whatever building you want to construct, you must necessarily do a site investigation. And site investigation, there is no alternative for that. You know, there are people who just dig maybe 60 centimeters or maybe 1 meter or 1.5 meter and then just put the foundation there. So that sort of thing which people do, if you are lucky, if it happens that at 1.5 meter, whatever depth you dug, the soil is strong enough, then you can have you'll be lucky to have a good foundation there without any problem. But in case the soil at that layer is not strong enough to take the load which you are going to transmit from the superstructure, you are in trouble. So soil investigation is a must. And recently many embankment failures and bridge approach roads and many of these kinds have been investigated by me. And unfortunately, let me say that a soil investigation had not been done in those places. A project of say 1 crore or 2 crore or 50 lakhs or whatever, you have a project of very high cost, all using public money, and you just do some kind of a construction without proper soil investigation. That should not happen. That in anything related to the foundation engineering, whatever you are constructing, soil investigation is a must. So So in this investigation, you'll have to look into the different details of that particular place. You have to have a site visit there. You should get the loads which are going to act on that soil due to the building which is being constructed there. Then you have to think about the soil structure interaction. Then you have to look into the properties of the soil. What is going to happen? I think after this we'll have a talk probably by Anil Kumar sir on cyclic softening. So these sort of things are going to happen. So what is it that you can do to uh, mm, um, to take appropriate action such that that is not going to affect you? Now, as far as the general soil investigation is concerned, you must preferably go in for rotary drilling or hand boring, whatever, and you must get a standard penetration test done. Standard penetration test is one of the commonly used tests, and we have a lot of correlations with the SPT n value. So that's why I would recommend you to go for the standard penetration test. And if you have a very large area where you can, you need to do a geophysical study, that also can be done using the different methods of um, uh, which are available. So then once you collect the soil samples, you have to bring it to the lab and you have to do the identification of the soil. You know that you have to do the index properties first, and then you have to do the engineering properties. Why do you need to know the index properties? You have to know what is the type of soil and what are its related index properties. So for that, it's a must. Once those things are available, then you can go into the engineering properties. So these are some of the tests which you will have to conduct, and these must be conducted. There is no alternative to this. You have to conduct a sieve analysis. You have to conduct. You have to get the soil classification, and for getting soil classification, if it is cohesive soil, you may have to go for the Atterberg limits and all those kind of things. So all these things are a must. Without this soil identification, there is no other option than to do that. You have to do that. Then you have to do the liquid limit, plastic limit, sink limit. These are the minimum things which you have to do at a certain site. Then, of course, once you collect the samples, then if required, you can do CPT, DMT. So many kinds of tests are there. You can do shear, direct shear, triaxial, so on. So all these tests that depending on whether it is soil or rock, you have to do all these kinds and get all the information from there. The strategy is basically you have to get the loads, and if there is a possibility of liquefaction assessment, I mean, this itself is a huge topic. You just have to assess whether liquefaction is going to happen or not. As I already told you, if n value of SPT is less than 10, you must be careful. If the water table is high, also these things together, and if the soil is silty and loose fine sand, you have the possibility of liquefaction. The analysis, of course, you can carry out a detail using the mathematical tools of it. So if uh, so if these things are done, then your job becomes much more easy. Now coming to the next part, the seismic design of foundations. You know that the foundation engineering deals with foundation structures, retaining structures, and substructures. In foundation structures, the loads are mostly vertical. In retaining structures, the major loads are horizontal. In substructures, the load can be in any direction. So we'll be in under foundation structures, we'll be seeing the shallow, the footings, rafts, and deep foundations, piles, piers, caissons commonly found. Then retaining structures also are very important. You are returning walls, sheet pile walls, coffer dams, all these things. So all these things have to consider this. But when you come to the seismic design, this foundation structures also will be subjected to horizontal loads. So this static classification is one side. When you go to the seismic side, your loads, unexpected loads. For the foundation structures, we only expect the vertical loads to act. We do the seismic design and we just ensure that it is safe. But when you go to the seismic side, it is not only the vertical loads which act, you also have the horizontal load. So you have not foreseen or designed for something, and that unexpectedly is going to come into the picture here. So that is one big cause of concern. In fact, that is one big reason why this subject itself has developed to that much extent. So the phases of foundation design, you have to do the structural design, the geotechnical design. Any foundation, you can do the geotechnical design. You have to fix the geotechnical design parameters, fix the foundation using the bearing capacity and settlement criteria. Then once uh, um, the dimensions of the foundation are fixed, in a shallow foundation, it will be the plan area. In the deep foundation, it will be the length of the deep foundation as well as the diameter of the deep foundation. So once that is fixed, from geotechnical aspect, if it is safe, see, in the bearing capacity and settlement are two independent parameters. One is related to the shear strength, the other is related to the settlement characteristics of the soil in that particular place due to the effect of this foundation. So in the two independent parameters, you have to look into both, and you have to decide that your foundation is going to be safe with respect to bearing capacity. It is safe with respect to the settlement aspect also. Then after that, you have to go into the structural design part, and then you simply have to just take the fix the thickness of the slab and all those kind of things based on this. This is the routine thing when you do the your normal seismic design. But when your earthquake comes, you will have to take the extra loads due to the earthquake which are going to come, and then your connection between the slab of a footing and the column, all these things will have to be rethought of. So you know that deep foundations and shallow foundations. Now, in the routine design of shallow foundation, your bending loads, this bending of this footing is considered to be the main. The bending stress is the main factor here, which you have to look. While in a deep foundation, it is the compressive load which is going to be the deciding the factor. Now, in an earthquake, what happens? Instead of bending, you may have some compression also, and there what predominantly the member was planned for compressive load, there you are probably going to get bending loads also. So the entire concept of seismic design is just, it is bringing out a big change in the way that we looked at the normal foundation design. So your entire concept has to change. In shallow foundations, you know the examples for that. We have the footings, raft, and all that. You know that for we can have either individual footings or continuous footings, or you can have combined footings. And you know that if you have more than 50% plan area of a building covered with individual footings, then it is economical, or it is better to go in for a raft or a mat foundation. So that's how we do the design for the shallow foundation. Once you have the raft, the shape, etc., all those things can be decided. Deep foundations, here we have the piles, the piers, the caissons. Piles, we have different varieties of piles, different classification of piles are available. And all those classifications, your way of analysis is in one way. If it is um, for a normal static loading, for the other dynamic loading, it is going to change. So this thing you'll have to keep into mind. Piles, small size, pier, bigger size, caissons, much bigger, and your loads are going to be much higher as you go from this side to that. Now, how do you choose which type of foundation you need to give? So for that, the first thing, you have to get the details from the superstructure. Superstructure, get all the loads at the foundation level. As far as the geotechnical engineer is concerned, loads at the foundation level are the most important thing. Once those loads are obtained, then we can do the soil exploration and find out at what depth the soil is strong enough to take up that load. So if you transmit that load at which depth, it will be safe. So once that thing is obtained for a static case, for a dynamic case, you'll have to think about in the similar way only. That concept is going to remain the same. That load, whatever load you're having, it should get transferred without any problem, without any distress, and it should also be economical. Now, there are so many varieties of this. Now, if it is not economical, what are you going to do? Yeah, it happens in many cases. It would not be economical to have the, the first option is the shallow foundation. The next option only is the deep foundation. The reason for that is shallow foundation is economical. The cost for that is very less. That's the reason we prefer shallow foundation. Deep foundation cost is very high. If you're not able to do shallow only, we'll go for deep. But in shallow foundation, if we are not able to do that, then we will also look into the option of ground improvement and strengthening the soil if possible, and then only we will go in for the deep foundation option. So in whatever be the case, we have to take into account the geotechnical design parameters, which are the bearing capacity and the settlement. Settlement, you can have different types. Bearing capacity derived from shear strength. You have different equations for that. It can all be used. So settlement, whatever be the settlement, you should be able to account for that into your this. So geotechnical design, in simple words, the net loading in intensity, it has to be less than or equal than the allowable soil pressure, which is the smaller of the safe bearing pressure and the soil pressure for permissible settlement. If you have a certain settlement, for that settlement, find out how much pressure you can apply, and then that value you will have to do and check and ensure that the net loading intensity is less than or equal to that is whatever load you're applying, it should be less than or equal. If it is higher than that, it is unsafe. If it is very, very less than that, it is going to be over safe and uneconomical. So this concept we will extend on to the seismic thing also. So whether it is a footing or a pile, we use the usual equations and then we do go on to that. Now we'll go into the seismic design of foundations. Now in this, as I told in the beginning, the ground shaking part. The ground shaking means it is basically acceleration. You have accelerations in the horizontal direction, you have accelerations in the vertical directions. Now, how do you take care of that? You know that the weight, whatever analysis we do a gravity analysis that is based on G. We do the analysis. So the normal designs and calculations and everything are based on that. Now here, as I told you, that you have mass into acceleration. If it is G, M into G will be the weight of that thing. So that weight you will have to ensure that it is carried down to the soil without any distress or any problem. Now that particular thing, when you have an earthquake, you have the different acceleration taking place. So that much, what extra accelerations come M into A. So that M into A will be coming extra. So that you will have to take into account, and then you'll have to ensure that your foundation is going to be safe under that extra loading which is going to come. That is the problem here. You have to see, we have one concept of factor of safety, let it be there, but your extra loading which is going to come is the one that is going to make your foundation fail. Then we have the problem of relative displacement. When this foundation is subjected to this earthquake, you'll have a dynamic response. We call it the soil structure interaction and effects, and due to that also the soil structure interaction itself is a quite an involved subject under normal circumstances without an earthquake. But when you have an earthquake, it becomes even more entangled. So it has to be dealt with in its own in its own right. So this relative displacements which are going to happen will cause some displacements on the building, and the whatever settlement you plan for, say your for normal footings, if we have the allowable settlement as 25 mm, for say raft, let's say it is 50 or 75 mm, or little more than that also. So here this, if due to this relative displacement during an earthquake, your additional displacements will cause problem to the building, because your structure is a manufactured thing. So that manufactured structure or building is planned and made for certain things. So it is not that it will take up any amount of settlement. So that if you are able to predict, well and good, we will be able to take that and we will be able to do. So then the cost is going to increase. Your client may or may not agree to that. So that you'll have to find some kind of a thing. You'll have to say that, okay, the building which I'm going to construct for you, that will withstand probably an earthquake of Richter scale 6. If 6.1 comes, finished. So that's how it is. So that is the only way in which you can speak to the people. Then earthquake shaking. Now this shaking, see the problem is the shaking. See now you can take the example of one bottle. Say suppose you fill your bottle with sugar. At home you can do this experiment. You can just put that, and once it is almost full, you just tap and you just shake the bottle, then the sugar level will it will come down. So that will happen if you have loosely poured the sugar inside the bottle. Now let's say you have already tamped and packed the sugar in a very tight thing in the bottle. If you shake that bottle, what will happen? The sugar will become loose and it will come out of the bottle. So that is what is going to happen in an earthquake, during an earthquake shaking to the soil. So if the soil at a place is loose, because of the earthquake shaking, it will get compacted. How it will get compacted, that we cannot say. Where it will get compacted, to what extent it will get compacted, nothing we can say about that. It will get compacted, but what will be the distribution of that, we don't know. It may get compacted here, it may not get compacted there, all these things. But the compaction will take place if it is a loose soil. So if it is a loose soil, then suddenly the if it has gone in, suddenly the foundation at that level, it has gone down, and so the strength will get reduced, the stiffness will get reduced. Or if it is a tight soil, due to this shaking, it will become loose, the strength of the soil will become less. And if the shaking is very high, settlement also can occur. So it is all dependent on what is the amount of shaking and how long it is going to be, and what is the type of soil which is going to be shaken. So this shear deformations, whatever you are going to have, it will be time dependent, it will be permanent, all these things are there. So this inertial loads of the building, they all can damage a building, and all these problems are there. So it all depends on what is the type of soil you're dealing with, what is going to be the effect of that. Then there is something called ratcheting. This is due to this cyclic loading. You know that in an earthquake, when this shaking occurs, your horizontal shaking or vertical shaking, whatever is happening, it will cause some foundation movements, and so that movement is going to cause some reduction in vertical bearing capacity, and it can also cause structural damage to the foundations. Then coming to the considerations of the foundation design, as I told already, all these things have to be taken into account. The soil response, site performance. See, in any such case, it is necessary that the person who is doing the foundation design, he has to visit the site. That is a must. You cannot simply get data from somewhere and sit and do the design. When you go to that site, actually you'll find, you'll understand that better. At least you can be sure about what you are doing. So that is one important thing, that once the designer sees the site, then you can do the whatever is to be done. Sometimes, we recently for one bus stand in Idki side, when we did the work there, we found that the soil is very porous. Very porous means you can have the foundation there, but the seepage of water from uphill, there is a lot of seepage under subsurface flow, seepage there. So that as when you do the soil sieve analysis, you'll get that. And then from, if this subsurface flow is continuing, the fines are still going to escape over a long time. So when this escape happens over a long time, this settlement and things are going to occur. So you must have a site visit in any place. Okay, then we have the concept of serviceability limit state. See, in serviceability limit state, you know that the structure which we are constructing, that should be in a serviceable condition. That is our main concept. So if it is in a serviceable concept and serviceable condition, we are happy. And so that generally it is seen that say it goes with the probability of 86% that all the problems which are likely to occur during the lifetime of a building will be taken care of with the probability of 86%. So with this thing, you can do the, this will be the most economical design if you follow this. So this see, for here, if you have liquefaction or cyclic softening, and if you have the serviceability limit state condition, the increase in settlement may be very high, and sometimes it may cross the serviceability limits also. So if it crosses the serviceability limits, it can happen. Then we will have differential settlements, tilts, and so on. Then we have the ultimate limit state. Ultimate limit state means that you all know that concept is that it is almost at the case at the stage of the collapse. So here our idea is that anyhow the building is going to collapse. So we should at least ensure that there is no loss of life. All the people inside the building should be able to escape and leave the premises as quickly as possible. At least for that much time, the building and foundation should be able to stand. So in the ultimate limit state, that should be the main criteria, that you should allow for people to escape and the loss of life should be minimized. Then intermediate limit states. Now, if you put it at the SLS, then it will be there. The possibility of risk is always high, and ULS, the condition is it will not be economical. You will not be able to spend so much money for that. So then you will have to decide at an intermediate limit state for your design. Once you decide at what intermediate state your limit state you are going to do the design, accordingly for that particular point, you will be able to do the design and carry out in a safe way. Now coming to the load and resistance factor design. This is slightly different from the normal routine kind of thing, but we have to take into account the loads as well as the resistance factor for the earthquake loading. Now, under this, we have three approaches. One is your equivalent static analysis method. Now, this equivalent static analysis method is similar to what I already told, that you have a force generated because of an earthquake due to a certain acceleration. You take that force and then you will do the that additional force will be taken care of and the analysis will be done. Then we have the modal response spectrum, which is a little more advanced. Then we have the numerical time history method. Numerical time history method is one of the popular methods. If you have the proper software, of course, the softwares for using this are costly. If you have that, then this is the best. I would just, my recommendation is always to go for the numerical time history method if possible, if you have the tools for that. The others are all you can do. If you don't have access to it, then somehow you have to do the design. You can do that, but this last one is a very good method of all these three. Anyway, we'll see this one by one. In this equivalent static analysis method, as I told, from each side, you will have to get the hazard spectra, and you'll have to get the once those details are available, you'll have to convert those into the static equivalent static loads. And then once these loads are obtained, then your building should be designed to resist these equivalent static loads. So the loads which you are going to use for the calculation, that is going to change. That is from the routine gravity based or whatever normal seismic design. For that, whatever we use, the loads which you will be using in equivalent static analysis will be different from that. So that you will have to decide how safe, what parameters you will have to have, and what will be your ultimate limit state condition. And accordingly, for this, you will have to do the entire calculation. So the procedure, what I already told you, that net loading intensity, it has to be checked whether it is less than the allowable soil pressure. Allowable soil pressure has to be lesser of the safe bearing pressure, and the permissible settlement for the permissible this thing. So on those concepts, you can do the design. Only thing is that your loads which you are going to use are different from the loads which you are going to use there. So that is the only change. If these loads are taken, then you can use that and you can fix the size of the foundation. Like I already told, the size of the foundation you will have to fix based on the bearing capacity and based on the settlement. So these two are independent geotechnical criteria. Based on these two criteria, you will have to decide and ensure that the size of the foundation is safe, to ensure that it is not going to have a shear failure. Then you'll also have to ensure that the size of the foundation is sufficient enough for settlement, not to exceed your ultimate limit state level. So once this equivalent static load is obtained, then you can just do the simple design and you can finish your foundation design work. Then the next is your modal response spectrum method. See this, let me just say about, like, you must have seen one, say if you have a string tied like this and you just vibrate it, the string can move around the center. It will move like this. So that is a single mode of vibration. So it will move like this, it will come back like this, move like this, and so you have the string moving like that. That's your single mode of vibration. Now, if you have, if you do the movement, if you excite it in the second mode, it will move in this way. So you'll have two modes of vibration will be there. So like that, you can have 2 modes, 3 modes, 4 modes, and so there are a number of modes of vibration. So for any structure, you can have a first mode of vibration, second mode, third mode, fourth mode, and those are all you can calculate from eigenvalues. You will be able to get all those things. So the modes are, like the possible ways in which that is going to act. So a building can act in any mode. We don't know what mode it is going to act. Mathematically, we can do the modal analysis for 1 mode, 2 mode, 3 mode, 5 mode, whatever. But you'll have to see for multiple modes how it is going to come, and then for uh, for a particular foundation, you will have to put an envelope that for this foundation, if you are going to apply that the analysis in different modes, how it is going to shake, how it is going to move, all these things you'll have to take care of. So mode response is another way in which not very much mathematically involved for simple cases, but as your structure becomes complicated, your modes of vibration, see the first mode, second mode, third mode, all these modes will change. So similarly, as the modes of vibration of a structure change, similarly for your foundation also, it is going to transmit all those things. So this, you can use a simplified approach in this case, where you can have the capacity design of RCC and structural frames, where instead of the equivalent static forces, you can replace it by the first mode of action. So whatever is in the first mode of vibration, what is going to happen? All those actions you can transmit onto the foundation, and you can do the design. So if you want to do a little more, you can do the 2 mode, then you can do the 3 mode. So all this nowadays softwares are available for doing this also. So if you have a software with you, things are going to be much easy. So whatever it is, even if you don't have a software, you're mathematically also by hand calculation to some small extent in small simple cases where you have one single column, one putting, you'll be able to do the calculation. So that is one way in which you can do. And the earthquake which is going to occur, the unknown earthquake which is going to happen there, that earthquake will have its own frequency, and this first mode will have its own frequency. If these two frequencies they happen to coincide with each other, then we will have the resonance condition. So that is the what you have to check. With each mode, you have to check whether this exciting frequency, whether this earthquake is going to cause a resonance condition. That is what you have to check. So if this value and the earthquake value are apart from each other, then no problem. Or if they are very close to each other, you have to do the design, and you'll have to do the you have to make some changes in the structure to ensure that the modes of vibration, all these things, the frequency, etc., the natural frequency of this and that should not coincide. That should be the concept when we do this. If they are if these two frequencies are away from each other, no problem, your design is safe. Okay, now coming to the numerical integration time history method. Now this is something which you can do only using the finite element method. You know that finite element method is uh, a very good tool to carry out any complicated analysis. Your finite element just gives you the ability to do things which were previously unthought of for analysis. So that tool is such a good tool that it can also be made use of now for this sort of an study. So here what we do is we will select earthquake records, and we will choose, like in our place now here we have this zone 3. In zone 3, what is the maximum earthquake which can happen? So that you'll with respect to the ultimate limit state of design, we'll check out what is going to be the earthquake hazard, and for that highest earthquake which we have, some other part of world it may happen. So you will get the time history. Time history means it will be a graph with on the x-axis you will have time, on the y-axis you will have the acceleration, either the vertical acceleration or horizontal acceleration, whatever. So those accelerations will be obtained, and here with respect to time. So you'll have a very zigzag thing, and then after that you'll have a peak, maybe 1 or 2 or 3 peaks or so, or more, and finally after some time it will just die down. So this time history, getting this time history uh, uh, is easy from earthquake stations. You will be able to get it nowadays. Many of these are available, so you can just download and get all those things. So if the time history is available, then you can do the analysis by inputting this acceleration time history. So what will happen is that you know that for a normal foundation the loads are applied, and then this soil properties will be given, and when you apply this, how much settlement is going to happen, you'll get to know. Now when you apply this earthquake record time history, actually when you have an earthquake, how this structure is going to behave, you will be able to see. That is the biggest advantage of this. So you can give whichever earthquake time history you want. You can give the for your particular place. If you want for a particular maximum thing, you can do. If you want to do for more than that, that also can be given. So the time history, if it is available, but for doing this, you will have to uh, do the analysis for different time histories. So if you can, for one foundation, if you can do for say up to 7 times, it will be very good, so that the worst case thing can be taken, because you'll have both horizontal, you'll have vertical, then you'll have all these things. So the accelerations in different directions are likely. So if you're going to have in those different this finite element model will be able to do it. Of course, depending on your software, you can have either the vertical or the horizontal separately, or if you have a good enough software for that, you'll be able to do that. Nowadays, this MSC Mark and is one good software which can you can use for this. Then Abacus also will be able to do that. Then the Plaxis to some extent is also known to do this. So this, if you have the proper software, you can do this thing, and it is one of the very good methods for doing the analysis. So in all these 3 methods which I told now, the equivalent static and the modal and this numerical integration, these 3 things can be applied for shallow foundation as well as for deep foundation. So any type of foundation you have, you can use these 3 methods, and whichever you are able to use, you can use that. So then if you are using this numerical time history thing, then it is basically a probabilistic assessment, and you can have you can choose whatever values you want. If there is some danger there, you can accordingly decide what values have to be chosen. After all, it's all a probabilistic thing. We don't know what is going to be the earthquake which is going to come in your place. So so here if you have the earthquake data, you can do your analysis, but at the same time your you must have heard of the constitutive models for materials. So if you are using RCC, concrete, whatever, for that you have to use the proper constitutive models. And if you are going to use the soils, you can use your Moore Coulomb, Drucker Prager, and so on. There are so many soil models, constitutive models available. All these models have to be used if you are going to do a finite element analysis using this time history. So, however, uh, uh, in all cases, your performance objective will be the same, but the basic idea is that the building should be able to safely carry the weight, and even if an earthquake occurs, excessive deformation which will endanger the safety and stability of the building should not occur. That is our main objective in all this. Then we can also go into this performance based design. Here there are it's a little more involved than that. So yeah, see, the thing is, always we have a question of this economy. The person who comes to a engineer, whether it is a structural engineer or a geotechnical engineer, he wants the most economic thing. So based on the economy, he will say that I want like this, I want like that. He will say so. According to his requirements, we can do the design. We can do the design and say that he asked for the design like this. Hence, we are giving this thing. So that is one way in which we can do. Now, if he tries to put the entire blame on you and he says that no, you tell me that it is safe, you must never do that. You can never say that. You must never say that my design of my seismic design of the structure or of the foundation is safe. You cannot give a blanket statement like that. You can only say that for these conditions it will be safe. Something more, something beyond that comes, nothing can be done. So that part you have to be very clear. So whether we take this performance based design or any design, your all these things will have to be kept in mind. So uh, you'll have a better control over the design, and the client says something, the engineer says something, you'll have a good um, uh, sort of approach there. So this is going to be the performance based design in the sense that it will be probably the codes of say the standard codes of each country will be able to give some kind of guidelines on how to do this. So this um, um, uh, in any such analysis, there will be a lot of uncertainties. So those uncertainties, anyhow, you will have to take care and ensure that to the extent whatever the soil properties or things are required, you can use that. Then we have this soil structure interaction modeling. You are found to see in any foundation, the load is applied onto the soil via a structural foundation. So during an earthquake, whatever you thought may happen or may not happen. So here the question is how the building is going to behave when it is in touch with this particular soil, and the behavior of that building is going to be different in the case of uh, um, different soils. So sandy soils, it is going to be different. Clay soils, it is going to be different, or any other type of soil or intermediate soil. All these are going to have a different type of this. The stable, the stiffness of your building and the stiffness of the structural foundation and the stiffness of this soil below, these two, when they interact with each other, when the load is coming, your redistribution of the contact pressure will take place, and it is this contact pressure, if it is too high, it will cause the bending and breakage and all those kind of things. So that will decide whether it is going to act like a cushion or whether some say some damping is going to occur or not. So all these things have to be decided using the soil structure interaction modeling. For soil structure interaction, there are many models which are available. Those can be used, or if not, you can even go in for a finite element analysis. Nowadays, that is the best way of dealing with this sort of thing. We have so many unknown parameters playing into this game. So whatever is known should be put down, and your finite element analysis is the only way in which it will be able to take care of this. Of course, you need to have a software. It's going to be costly. All that is there, but still, to a big extent, you need to do the soil structure interaction modeling. And for important structures and big structures, consultants are doing soil structure interaction modeling nowadays. Now, yeah, if you have a look at this in the finite element dynamic analysis for the slope. So here you can see that how this along this interface, this changes are going to occur. So this entire slice, it will just simply slope. So you can do a modeling like this on the computer, and then you can have your good analysis. Or previously, this sort of analysis could be done only using. You'll have to draw it on a graph paper. You'll have to use the compass. Nowadays, who has the compass? Very few people have. Only people with small children in their home will have compass. But otherwise, engineers nowadays, it's not being used. So that sort of a thing, all those things can be done if you are going to do a non-linear analysis using FEM. Now, coming to the foundation selection process, and the foundation selection is always it's a work of a judgmental nature, like how you choose out of so many options. There are so many things which are to be looked into, and out of that you will have to select one thing which gives you uh, the best option for that particular place. So in place where you have the possibility of liquefaction, you have to ensure that wherever uh, such a possibility is there, proper soil investigation has to be done. And once you know that liquefaction is going to take place, then if you can avoid that place to uh, uh, then well and good. If you're not able to avoid, what will you do? If you're not able to avoid, you'll have to go for ground improvement. Nowadays, land is not as easily available as it was, especially for big projects and all. So in such places, you will have to take into account the type of soil there and how it has to be. In fact, for this the Kayankulam CCCP project, this naphtha diesel project there, they have dredged soil from the sea, and it is mainly silty soil, and it was stamped there using dynamic compaction. Dynamic compaction, they used some 2 meter by 2 meter size steel plates raised about of weighing around 1.5 ton. It would be raised to 20 meters and it would be just dropped. So that sort of dynamic compaction is done. So wherever you have this possibility of this liquefaction, you have to go in for ground improvement. So once the soil becomes strong enough, and after the ground improvement, when you do the test, if the N value is above say 10, 12, then you may not have that possibility of liquefaction. So you have to either avoid the place where liquefaction is likely to occur, or you will have to do some kind of a ground improvement study and the ground improvement there. Then we have the question of place where you have this lateral spreading. Now, if you have this either liquefaction or otherwise, when lateral spreading is occurs, lot of soil will just simply move and flow away. And usually liquefaction also may be a part of this thing which is going to occur. So this, if the depth of lateral spreading is much, say 3 meter or 2 meter, if it is below the depth of the foundation that you have given, your building is gone. Your building will simply flow. In some 2018 floods, we could see some videos of houses flowing from one place to the other. So that is because the foundation was given only at that particular depth. Had it been given to a much more depth, we don't know whether it would have stood or not. But comparatively, say we could say that at least it would not have just flowed and moved like this. Of course, there are many factors which decide those things. But if your foundation is resting in a zone where you have lateral spreading, it will simply just go. So there also, if you know that it is such a place, either you avoid those places or you go in for some deep foundations in order to ensure that your building does not get carried away. See, this is the thing. Now this lateral, say here it moves by 0.5 meter, then 1.5, 2 meters to 0.53 meters. So as you go away towards the river or towards the sea, whatever, then you will have this lateral spreading. So this house will also move if the footing is at this level. If the foundation has gone down and if it is strong enough to resist the horizontal movement, it may. So that's how it is. So how we are going to predict the location, scale, intensity, and all that, that is all a big question mark. We can do soil investigation properly, and to some extent we will be able to say that by saying, see, all those things involve a lot of money. Your cost is going to be high, and it can be done, but if you want to save money, and if you also, you cannot have the cake and eat it too. That's what they say. So that's how it is. So the cost which is going to be spent for this thing that is going to be very high, and then the lateral spreading, earthquake, all these things, the associated risk factors are all to be done very carefully. Then we have the site stability issues. If you have a sloping ground, very easily your entire building will slope down if there's an earthquake shaking. If you have cuts, if you have fills, if you have retaining structures, all these things, you will have to decide what is your the serviceability limit state or the ultimate limit state, and accordingly for that you will have to take a decision. Because in all these places, site stability issues, to some extent you may be able to take care of that, but not to a big extent. If a big landslide or thing happens like that, nothing can be done. Then coming to the settlement part, say your building can have a lot of settlements, and this settlement from the point of view of the building, wherever you have weak and loose soils, this settlement is going to be higher. If you have strong soils and if you have a strong building, strong structure on top of that, it will be able to shake and remain its own place. So your settlement, wherever you have loose or weak soils, that is wherever you have loose soils or soft clays, you have to be careful about the possibility of settlement. So there are many causes for settlements. Any or many of these causes can contribute to it. Then this, of course, we also know that apart from those other natural phenomena related causes, we can also have building induced settlements. So this, the load, ultimately you are making a foundation for transferring the load from the building. So that building load will also induce settlements. For a footing, you know that we usually go for 25 mm permissible. Then for a raft, maybe 50 cent for 100 mm. So like that, we will for a combined footing, we will more or less. So like that, we will have to decide what is going to be the settlement which is going to occur. So your loads for this, which are going to cause these settlements, you will have to take those into the design and ensure that the loads are less enough so that less settlements are produced. So you can just have this look on this, how this due to ratcheting, how these things are shaking. Then you can have the rotational failure, the punching settlement, then tension here, compression here, all these kind of things will happen. If you have these sort of situations in this ratcheting or rocking kind of thing, it is all a complicated thing. We can give the foundations appropriately, but your numerical time history will be able to give you a proper prediction of these kind of things. Your other techniques will not be able to tell you what is going to happen under this situation. All horizontal things. So this thing can be done, but of course it is going to be expensive. Coming to the shallow foundations, there are a number of things. So these are what we saw until now are the general things regarding the shallow as well as the deep foundations. Now, in shallow foundations, the basic idea is that the bearing layer should be thick and strong enough, and it should be able to take up the load without any punching failure or shear failure. So, one thing you should keep in mind is that don't allow a building to be made part on shallow foundation and part on deep foundation. So if you have it as two separate structures, it is okay. But same building connected on one side it is this and one side that. During an earthquake, the action of these two parts is going to be different, and there's a possibility of shear. So don't combine this. Although we have done for buildings in some places with shallow as well as deep, depending on the site conditions. But if you are aware that that place is an earthquake prone area, then you better not go for that without a structural separation. At least, like expansion joint sort of thing, you should give some kind of a separation if you're going to give two different types of foundations. Then coming to the shallow foundation design, as well as the whatever footing or pad, whatever you use, you should ensure that the connection between the column and the slab, the footing at the bottom, that is very, very important. That it is mainly in many places at that connection that it will break. The loads, the horizontal shaking and the problems are not able to, the loads are not able to get transmitted down from the superstructure to the foundation at that particular point. So that is a weak point. So that weak point is what you do. Once you do the design properly using any of the methods, you do the equivalent static, or you do the Modal method, or you do the numerical time history. Here the question is, you have to give the proper connection between the column and the footing. Then here you can have strip footings, you can have pad footings and all this, and that in any such case, your ultimate limit state has to be taken care of. So this ultimate bearing capacity and all those things, your factor of safety taken for that, all that has to be accounted for. See, factor of safety should be greater than 2 for seismic case, that we say, because the loads, the equivalent static loads which will be taking will be higher. So from that point of view, you'll be able to get a safe design. Then, of course, in shallow foundations, we have a lot of uncertainty in soil strength parameters, because during an earthquake, how it is going to change. But a proper laboratory, detailed laboratory testing at any place will give you a proper idea about the soil, whether it is loose or whether it is soft and all that. So you can predict, or you can choose to modify those properties and ensure that you are going to get a good behavior out of the soil. So all these uncertainties, one by one, you have to deal with these uncertainties. what you are going to do, what you're not going to do. If it is loose sand, what you're going to do. If it is soft clay, what you're going to do. Whether you're going to improve it, what is the technique of improvement, how effective that technique is going to be. And in any case, at the end of it, you will have to do an test again in the field, and you have to find out how effective um, your work was, and then you'll get the new parameters, and those new parameters have to be see, sometimes in many projects we do the design. Once for this Reliance, when I did the work, they gave for this a ready-made set of this for the 5 ton per meter square SBC, 10 ton per meter square SBC, 15 ton per 10 inter square SBC. For different SBC, they've given the thing. So you have to choose. So that there are offices and practices who do that. If that is not possible, if it is a large scale type of work which you are doing, then you can have those sort of things done in your office. But otherwise, you need to have a proper look into the laboratory test, and from the laboratory test you have to finally decide what is going to be the SPC, the allowable soil pressure, and then you'll have to do the calculation and do that. Then you'll also have to look into the scale effects for large footings, small footings. Your in the analysis, you may not be able to do the large analysis. You'll have to go for a smaller one. Gravity design procedure, I think I've already told. So it is similar to what we usually do, the normal case. So here, just the ultimate limit condition will be taken care of. The usual procedure. So here we just have to do this, what I've already told. You use the bearing capacity equations, then you check for the settlement. Bearing capacity and settlement are the two important geotechnical parameters which you will do the design. Now, in the case of seismic design procedure, you'll have to take into account what is going to be the behavior of the soil, what is going to be the serviceability limit state conditions, then the lateral load path and all these things for the building. So take these kind of things into this thing, and how, if this building is going to move horizontally, shaking or whatever, how much resistance you will have in the side, that also will have to be taken into account. Then you'll have to check for the ultimate limit state. Then I think this is not so you can have proper beams if you are going to have a mat foundation. I mean, raft foundation with beams, generally it is a mat foundation with beams. It is generally considered to be a raft foundation, and that will be more rigid in comparison to the pure mat. You can also use this natural raft. Okay, the basic idea of the shallow foundation is applicable for mats and raft also. Since we also have a little more to discuss, I think I'll quickly move over here. The possibility of edge failures in mats and raft are there in the case of this earthquake or even otherwise. So then we will have to take care of the possible strengthening and ensure that it does not fail. The gravity designer the procedures are also the same as the thing. Seismic thing, as we already told about the shallow foundation. Similarly, the soil, the type, the site effects, you'll have to check. Then your serviceability settlements and those kind of things. Lateral load path, then the ultimate limit state thing you'll have to check. Then coming quickly to the deep foundations, you know that when we are not able to have a shallow foundation, we will go in for a deep foundation. Deep foundation, it can be piles, piers, or caissons, and there, in whatever this, if it is a friction pile only, it will be standing in the soft layer. If otherwise, generally your deep foundations will be going and resting onto hard strata at the bottom. But one thing is that See, the piles, it is not really recommended to have them found at different bearing strata, that you know that soil will be in layers. So one layer will be strong, one layer will be less strong, and so on. So don't end your in one place you'll find one layer, in one place you'll not find a layer. So if you have that sort of a situation, don't rest your piles in two different strata, especially with respect to this earthquake kind of thing. So if you the 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 transmission of this earthquake vibrations and this all that, for one particular type of soil at one particular depth, it will be having this. When the layer changes, how this the S waves and all those P waves and all those waves, how they are going to get transmitted is going to change. So that is going to affect the performance of this piles that we have constructed. And also you have to ensure that uh, you are not resting any pile onto a boulder strata. In Irregularity for one college, when we did the investigation, we found that at one point the rock was at 15 meters. At another point, when the piling was in at 9 meters, they found hard rock. So and finally, after some time, we understood that it was actually a boulder of huge size, around 2.53 meter size. So those kind of things happen. So soil investigation is a must in any case. So then you will be able to decide where you that in which strata you will have to rest the foundation. So only in the same type of strata you must rest your foundation. So this the design using those any of these methods, you can do the thing. Now see one thing recently in the Cochin for the Palarpadam, we had to check out one pile design. See, there in that area, you know, we have piles which are more than some 70, 80, 90 meters long. And the hard strata is at that level only, and you can transmit the loads only at that level. So that the question comes, see, when you have an earthquake prone area, and when you have a soil where you have a possibility of liquefaction, there is a recommendation which says that the L by D of a pile should not exceed 50 if you are going to have that pile in a liquefiable soil. But in Cochin, there is no way out. We cannot have a say if you have a 100-meter pile, just think to L by D 50 means you have to have a 2-meter dia pile. That's not a practical thing. So if it is say 75 centimeter, 1 meter or something, okay, somehow for that depth we may be able to do this. So there are things like that. So and if you think that after soil investigation, if you feel that at that point a lot of a high possibility of liquefaction exists, then you have to apply that thing. But in any case, you can always do the analysis, and you can ensure that even if the LYD is less than 50, your pile can be made safe. You can do structurally, you can make it strong and things like that. The possibility of slender piles buckling is what is of concern. So L by D 50, that thing which we have, that especially with respect to this our topic, that is one thing which we have to keep in mind. So people will say that L by D 50, more than that you should not allow the piles to be constructed. So that now there are techniques where you can go for beyond that. You can change your grade of the concrete, you can change the reinforcement of the concrete, you can carry out a complete analysis of this thing. Your time history can be done. So it is possible for you to have a pile designed according to your this. It is all these recommendations were made over years. So you can take the freedom as a designer to take care of, to make modifications in what people have said. See, new challenges will come. So you have to rise up to the occasion and you have to give the solutions for that. Of course, heavy loads, everything will be there, but experience is there. People with experience will not allow you to do that, but you have to take a bold step and you have to say that in this case it is going to be safe. Of course, you have all the backing up of your analysis and all that. So coming to this again, this design part, lateral movements are also a big problem inside at the depth of the ground. Movements can occur, that also needs to be taken into account. Now, many deep foundations, you'll have to look into it in detail. So this another problem is your down drag post liquefaction. We have this negative skin friction, which you all might be knowing. So similar to that negative skin friction, if an liquefaction has occurred at a certain place, after the liquefaction, the soil particles will again settle down. So then you will have a down drag. So that means the load which was acting on the sides of the pile, that load will increase to a higher level, and whatever design you have made will be unsafe. So that is one big problem. You have to take that into design. The capacity of the pile is going to reduce because of that, but this phenomena is a possibility. So just like the negative skin friction in the case of the normal case, this down drag also will happen. So this thing has to be taken care of. The gravity design procedures, the usual ones which we always use for piles. If you want to do, you can use geotechnical soil models for this kind of a calculation. Check for settlement. Then in piles, of course, there is one more thing that you have to do. Is, apart from the design, you'll have to do a drivability check, whether you are it is practicable to drive the pile to that depth. Of course, that if you have done the soil investigations before that, you'll be able to get the details and you'll be able to tell. So then your spacing of the boring, etc., is important. So if you do the boring at regular intervals, you'll be able to get the complete thing. Or you can also do the wave analysis, wave equation analysis, and all that also can be done. Nowadays, we have all these kind of techniques. So this you can do, and load testing also is a must, because before going for the construction of the superstructure, you will have to do a load test and ensure that that is able to take up that much load. So once the load testing is passed, then you can go on with the construction of the superstructure. So seismic design procedures also similar to what we have told for the shallow foundation. So here the building dynamic response, the base shear which is going to come, which I told that the you have to give sufficient and proper reinforcement at the joint of the column and the footing. So those things have to be taken care of. Then the axle load, capacity and settlement, all these things, as I already mentioned, that in you have the equivalent static load that you can do. Then the soil and site effects, the soil type, all these things similar to what we have already mentioned. These things also have to be checked for. And this buckling also, that issue I've told that is a big issue in this Y by that L by D ratio of 50 km. Beyond that, you can strengthen and stiffen your pile. Then the lateral load resistance of pile also is an important issue. That the analysis for that also has to be done. And once it is safe, you can proceed with the construction. Then, of course, you have this liquefaction and the how you do the calculation of limiting equilibrium calculation. So that whatever, so if liquefaction is not there, well and good. If you are going to have it, you have to take into consideration. I'm not going into this. I mean, all this kind of analysis can be done. Okay, so that is about the shallow and deep foundation part. Then the other, very quickly, I'll just tell you how to do the soil improvement for mitigation of the seismic hazards. The ground improvement, basically it is strengthening. So you have two different ways in which how you can do for sandy soils and clay soils. Once the improvement is done, then we will be able to get a better resistance against liquefaction. You can use densification techniques. By densification techniques means you will have the particles placed close to each other. That is the idea. If the particles are loose, you will use some technique and you'll ensure that it is closely packed. So for that, you can use vibration. Through vibration, you can make these things come together. I'm not going into the video. You can have dynamic compaction. In this, your heavy weight is dropped from a large height, as I told you, like for in Kayankulam, how it was done, from 6 to 30 tons. And your height 10 to 30 meters, it can be lifted and dropped to the number of times which will give you enough densification. I think there's no time for showing all this. Okay, then blasting. Blasting is another densification method. You just drill holes and then you do the blasting, and once the blasting is done, all these particles, they'll become dense. So you'll be able to see that once the blasting is over, the level of that particular area will go down. How much area you have to do the densification, that depending on your requirement, you know that any structure you have to see the zone of improvement, and accordingly you'll have to decide the area which has to be denser. Then the other technique is using reinforcement. There are different materials which you can reinforce the soil. You can use the stone column technique. You add stone columns into the soil and you compact it. That can be done, or you can use compaction piles. They can be driven down. They are also called displacement piles. If you are using compaction piles, you should start from the center and go outside, not from the outside. If you come inside, you'll not be able to do the work. Then drilled inclusions, you can just drill and you can add things there. Like you can have the soil nailing kind of thing. Then grouting and mixing techniques, you can add. See, there are different types of grouts available. A high pressure grout or whatever, you can just mix into the soil in different grouting, intrusion, permeation, then soil mixing. Then you can have drainage techniques for ground improvement, dewatering techniques, some pumping, deep well construction, freeze method of dewatering, then chemical consolidation, then cement grouting method of dewatering, well point method, electro-osmosis. So depending on the site conditions and the cost and all that, you can decide what is to be done. So thank you. So if you have any questions, you can feel free to ask.
Thank you so much, sir. This session was very informative. We could gain a lot of knowledge about earthquake resistant design foundation. Now the forum is open for discussion. Participants can either type their queries in chat box or unmute yourself and ask questions. If there is any queries, you can ask.
I hope you have got an idea about how things have to be done. Yeah, actually, yeah. The question is, will liquefaction occur because of blasting? See, liquefaction, yes, there's a possibility of liquefaction. When we do the blasting, uh, a sudden vibration comes. A sudden vibration comes, and then it causes the loose soil to settle down. So that is one possibility. After all, uh, if, if if the liquefaction can occur because of an earthquake, earthquake is basically a vertical horizontal acceleration or movement. So anything which can cause that also can do the same thing here. Blasting or any other vibration, but the extent will be different depending on how much of vibration has happened. Will decide the extent of it.
Participants, you can ask what questions.
Okay, the other question, instead of retaining wall, what are the other advanced methods? You mean for retaining the soil? Instead of a normal RR retaining wall or RCC retaining wall, we can go for your reinforced soil. You can have those kind of techniques. You can have gabion wall. You have this. Uh, uh, you can have this uh, green. You can avoid a retaining wall altogether if you plant bamboo and those kind of course, if the slope and all those things are conducive, you can plant bamboo trees and you can have this wet river. You can use that. Those things can be planted. In fact, in Sikkim, they took this wet river. I think it's called Ramacham in Malayalam. So they took that for a huge stretch of the national highway. They had this thing taken from Kerala and planted there. And it was found very effective. For up to 3 meters, it just grows like around 30 centimeters thick roots. They go in and they just spread in and they hold it. So depending on what is the height of retention, what is the type of soil, you can decide uh, uh, which method you want to use. Retaining structures itself is a huge topic.
Any other questions? Thank you very much. Okay, sir. Thank you very much for your questions. Thank you. Feedback link will be shared in chat box. Okay. Thank you.
There is no doubts or systems. Thank you so much, sir.
We'll start the next session by 11:50. Good morning, all. I'm Nisha Verghese, Assistant Professor, Department of Civil Engineering with the Academy of Science and Technology. Due to some unavoidable reasons, for Mr. Anil Kumar, Professor G.C. Trishu, next session will be handled by Dr. Justin Joshi, Head of the Department, Civil Engineering Department with the Academy of Science and Technology, on the topic Reasons, Effects, and Precautions of Earthquake. Now, let me welcome Dr. Abhilasha P.S., coordinator of FDP, to introduce the speaker of this session.
Respected Justin sir and dear participants, very good morning to all of you once again. Let me share my screen. I hope screen is visible to all of you. So it's great pleasure for us to have Dr. C. Justin Jose, a professor and head of Department of Civil Engineering with the Academy of Science and Technology, Thrissur, Kerala, that is our own institution, to handle the last session of our 5 days online FDP sponsored by ACT Adel. And his topic is Reasons, Effects and Precautions of Earthquakes. And coming to his biodata, sir completed his PhD from NIT Calicut in structural dynamics topic in the year 2013. And he completed his structural engineering MTech from CET, College of Engineering, Trivandrum, and BTech from Government Engineering College, Thrissur, in civil engineering. And he's got 8 years of industrial experience in different construction sectors, which includes 6 years at UAE. And he's undertaking civil and structural consultancy works for the past 20 years. He has also got 15 years of teaching experience in UG and PG level at the Academy of Science and Technology and 3 years of research experience at NIT Calicut. He has published international journal papers and international conference papers and national conference papers in the recent years in connection with structural engineering. So we are blessed to have you, sir, here with us for delivering the session. Warm welcome, Jason, sir. Sir, you can share your screen now.
Yeah, okay. Thank you, Dr. Abhilasha. Am I audible now?
Yes, sir, you are audible, sir. Yeah.
Okay, thank you. So let me share my slides. Yeah, is this visible? Okay. So good morning to one and all. This is actually a substitute session. We were eagerly waiting for Professor Anil Kumar because of some unavoidable situation. We are handling this subject. So basically, this particular topic, we plan to make a review of all the topics which we covered in the last 5 days, including today. In the last sessions, we identified what were the basic reasons for earthquakes, what are the effects that is happened to the structure in different aspects. Different aspects means in the aspects of structural level as well as in the geotechnical level, and superstructure level as well as the foundation level, and the soil structure interaction, and different configurations, etc. All these things we discussed and explored. And many of these sessions were entered with the precautions, but how we can overcome this situation. We cannot stop earthquake, but how we can overcome the earthquake effects. This is what we discussed so far. So this particular session is actually a superficial session. We are not going to any detailed design or any detailed discussions regarding any of these matter, because most of them are already covered in the different sessions. So as I told you before, this will be a review session. And of course, this is a last session for this particular FDP. And let me congratulate all of you, and we are expressing our gratitude towards all the participants because we were conducting this one first time as a sponsored program, and Dr. Abhilasha and her team worked very well to organize this program in a beautiful manner. I hope all of you enjoyed these sessions and you made a happy learning in between. So let me go through my discussions and later on we can make a general discussion about the topic, and also we can make an interactive sessions at the end of this particular topic. This is my plan. Anyway, let us start. Am I okay, Dr. Abhilasha?
Yes, sir. Perfectly okay, sir. Please continue.
Yes, thank you. So as I told you, the session is basically divided into 3 different parts. We are going to discuss reasons for earthquake. Dr. Katta sir is explained about the very detailed manner, but even though we are making a small refreshment about refreshing of the same topic. Then the effects of earthquake on structures and precautions for earthquake effects. So these are the broad areas of discussion which I planned with you. Now, reasons for earthquake. This is the inner core. I'm not going to explain you much. So this inner core is the root cause of these earthquakes. So these are the general classification of the inner part of the earth, where the inner core is solid in nature, and you have a crust and mantle. Upper mantle and crust will move. So the crust has these are the details about crust. Approximately 1% of the total volume of the earth is crust. And there are oceanic crust as well as continental crust. They have the thickness has also, this is a variation of the crust thickness, and the density is also mentioned in the slide. I'm not explaining you much. These slides will be shared to you also, so everything will be there in the slides. Then we have the mantle. We have the upper mantle and the lower mantle, and this upper portion of the mantle and the crust together is known as the lithosphere. This is the point where we have to start with the discussion of plates. So the plate tectonics or plate theory, it starts from the upper mantle and the crust together. We consider plates for this. So these are the details of the upper mantle, its thickness and its density, and the type of the major plates are based on upper mantle and the crust together. And this upper mantle is moving above the molten lower mantle. And thickness is also mentioned here. Ionosphere is known as this one. And when we enter into the core is also known as knife. It's a nickel and a ferrous or iron. So this is the inner and the outer core are also there, where the inner core is considered as solid state because of the solution, and it's very hot, and its density is also 15 compared to the above portions. It is more than 5 times density. And outer core is again, it is outer core as well as this molten metal stage, and the thickness density is also mentioned here. And here onwards the plate tectonics starts. There are major 7 tectonic plates, as you are aware, and they are spread all around. Before these 7 tectonic plates, it was only a single plate back now. And this one was later on around more than 300 million years, it is separated, and these major 5 tectonic plates are considered now. And these are the pancua. It is spread into different 7, then later on more than 7 like that. The continentals are formed based on this movement, and this movement is continuously happening now also. So that is the basic reason for earthquakes. We know that. And this is based on some evidence. When we consider the South America and African border, we can see that some fit of continents, we can see that this is one of the evidence. Then geological features, fossils, all are similar to these areas. So this is the basic reason why we are considering the so-called plate tectonics. And the height of the Everest, Himalayan mountains, is getting, the height is increased by approximately 2 centimeters per year. These all reasons based on the movement of plates above the country. So this is a background of the reason for earthquake. And when you go through the history of earthquakes that is happened in the previous years for the last 200 or 300 years, we can see most of the earthquakes that happened in these interplate areas. So we can classify the interplates in that way also. These are the red color marked is the earthquakes that happen. Many of them are under ocean. So that is not happened. That is not made any effects to the human being. So based on this proofs and evidence, we can say that these plates are moving continuously, and the rebound hammer, the elastic rebound theory, that is elastic rebound theory, is the background of all the earthquakes. And sometimes if it is happened in the ocean, this will be the tsunami and volcanoes, etc. All the natural level calamities we can explain based on the elastic rebound theory. Okay. So these are the basic reason for earthquakes. So far we are considering in that way. Then because of this elastic rebound theory, there are seismic waves or energy dissipation or energy propagation that is happened. And this is due to the seismic waves. Generally, we divide the seismic waves into body waves and surface waves. And body waves are classified into P wave and S wave, where P wave is longitudinal waves and S wave is shear waves. S waves will not pass through liquid media because shear will not be there. Shear forces will be zero when you consider the liquid media. And these are the primary and secondary waves also. It is known that way also. They are called body waves. And we have the surface waves. We have Rayleigh waves and Love waves. When we deal with the building and its issues, mainly the surface waves will make issues to these. So P waves and S waves will reach to the area from the focal length and photons, even though the surface waves makes disastrous issues in the when we deal with the building and the infrastructure. Now this is actually the P wave propagation. The direction of propagation is marked here, same as the compression and tension. It is actually the longitudinal wave. And in the case of P waves, because of the different media in the inner core of the Earth, there will be possibilities of refractions, and these refractions will cause us some shaded area. Some areas we will never experience any type of earthquake waves because of the refractions and because of the different media inside here. So in the P waves, they are also known as shadow zones, where earthquakes are not experienced in that time. That is also identified by the researchers. So some areas we don't have any earthquakes because of these reasons. Then in the case of S waves, they are, as I told you, they are the shear waves, and the propagation of S waves is due to the shear and the water media, or the if you are looking for the liquid media, the shear strength will be 0, and shadow zone for the shear waves or the S waves is much more than P waves, because the when it is enter into the molten region or the where you have the liquid region, the P waves will not be, I mean, S waves will not be propagated through it. So the shaded portion for the S waves is comparatively much higher than the P waves affected. Now, when we enter into the surface waves, okay, the surface waves are generally classified into Rayleigh waves and Love waves. These are the propagation and the movement of the particles. They are basically acting on the surface. So that is the reason why the infrastructure is mainly affected by the surface waves, and more destructive issues are taking place because of the Love wave and Rayleigh waves. These are the Rayleigh wave. In the Rayleigh wave, the propagation of the inner particle will be in an elliptical model, and energy dissipation direction is also shown there. Now, in general, the earthquakes can be classified into 5 types based on the source and the plate boundaries. They are interplate at intraplate. Intraplate means the earthquakes that is happening inside a particular tectonic plate. And then, based on the focal depth, you have the long and short earthquakes, and also the different classifications are also based on the focal depth. Then based on the origin of the earthquakes, what is the reason for it? Man-made earthquakes are also sometimes we are explained because of the man-made activities. The huge, if you have a reservoir which is man-made, and similarly man-made activities enforced, all this makes some restructuring of the earth, and this is also causing the origin of earthquakes that are classified. Then finally, based on the magnitude, we have the minor earthquakes, moderate earthquakes, and severe earthquakes based on the magnitude. If the magnitude is less than 3, we generally name it as a minor earthquake, and if it is between 3 to 5 or 3 to 7, we have the moderate earthquake. Then if it is more than magnitude 7 Richter scale, maybe it is known as also a major earthquake. So these are the basic classification of the earthquakes. Seismographs are the instruments which we capturing the earthquake and its presence. There are electronic equipments, more sophisticated equipments are also available. The station points are already marked in the earthquake prone areas. The worldwide, there are many station points in the earthquake prone area where each and every tremor will be recorded, and it will be analyzed. And based on the recorded data, we have facility to recognize its magnitude and peak ground acceleration and other parameters of the earthquakes. So seismographs are popularly known as the station points. So I mean, they are capturing the earthquakes. These are the basic terminologies which we are using in the earthquake, where we have the focus considered as the origin of elastic rebound issues. Then the fault or rupture will be there. Focal depth is considered as the perpendicular distance from the ground. Then the focal distance is actually the focus and the place where we are looking for the station point or something like that. Then the epicentral distance, etc. All these parameters are used to estimate the energy release or the volume of amount of energy energy released in the earthquakes, and Richter scale we estimate in that way also. Now, generally the earthquakes are classified based on the magnitude and the intensity. That is also very common to all, where magnitude is a quantitative measure, the energy release, it can be calculated by this expression, whereas the intensity is a qualitative measure, depends upon the population and the destructions that is happened on the because of the earthquake. You have the heavy intensity. So if an earthquake that is happened inside the ocean, even though its magnitude is much higher, maybe the intensity will be less because of the effect on the human being, and the death rate may be very less. So the intensity will be less. That is the basic difference between these two. In India, the entire area is divided into different seismic zones. All these things are we know very well. Now Kerala is upgraded to zone 3. It was before zone 2. Now zone 1 is completely removed. The red portion, as you know, they are the zone 5, where the earthquake may occur at any time. Earthquake prone areas, especially for the Himalayan region, northeast states, as well as the Gujarat, etc., considered as this. So all these data are available with us to make an understanding about the design against earthquake effects. We cannot make design totally against earthquake, but the effects we can identify based on the previous history of the earthquake. Then later on we can decide accordingly. That is the way we are making the earthquake access design. Major earthquakes that is happened in India, also we can see that they are in the interplate regions, whereas the major earthquakes happened in the Indo-Australian plate and Indo-European plates, where the magnitude is sometimes more than 8 major earthquakes is happened over there. So all this history is giving us a eye-opening, and the major constructions while we are doing in that areas will take care of the earthquake effects. Accordingly, we have to make the design. These are the major earthquakes that is recorded in India. Many of them are more than 7, and its date is also given. Death rate is also recorded. And in 2001, actually the Latur earthquake in Gujarat, all these things is an eye-opening for the revision of Indian codes. So 2002 Indian code is revised based on the impact that is happened in Gujarat. The magnitude of the earthquake was 7.7, and the prepared all earthquake guidelines are modified. Now 2016 it is still modified. As we know, it is a very hot area where the researchers are doing a lot of work for the understanding and overcoming the earthquake effects. So based on the revision of the code is also proposed by the researchers. That is the reason why the 2016 code is also going to be revised in a different way that is not published so far. These are the major earthquakes that is happened in the world level, where the 2011 Pacific Ocean, actually there is a very big earthquake of magnitude 9.1. That was the major earthquake recently happened in around 10 years ago. So this is it's a continuous process. The uncertainty behind the earthquake, as you know, there is no provision for the prediction, but we can assume these are the prone areas of earthquakes, and the magnitude also based on the previous history, we'll get an idea about this much of earthquakes or the magnitude of earthquake may happen, and its occurrence and its frequency, etc. You can approximately estimate, and based on that we can make the design. This is what we are doing. That is a limitation which is. Now the peer ground earthquake motion data. This is a website. Everybody knows all these things. There the major earthquakes and its data available. Now the reliable softwares are also available for us to make the similar effects. What will happen to a modeled structure in ETAPS or SAP, and how it will react against the earthquake which is happened recently in that particular region, so that we'll get an overall idea about how we can go through the design procedure, etc. This database is available for the researchers and the interested people. They can go through it, and they can find the magnitude and the details of earthquake data from that. So these are the basic idea about the first part, where we discussed about the reason for earthquake and the data available, and also what are the basic classification, history, etc. So based on this idea, we will get an idea about how we can design the earthquake force on the structure. When we go for a design, we should know what is the effects that is happened to the structure because of these earthquakes. So these effects of earthquake on the structure that we are going to discuss now. The first one is its inertia force on structures. The lateral forces acting on the building, and this lateral forces is undergone and converted into finally inertia forces. And this inertia forces will pass through the columns, and these columns will transfer this one to earth. This is actually happening because of this earthquake that is happened on the surface of the earth. This will become converted into as inertia forces, and these inertia forces will affect the entire structure. So we have different methodology to identify the estimation of the inertia forces on the structure due to the earthquake. Lateral forces. Usually it is entirely different from the gravity analysis. It is a lateral load analysis. The inertia forces can be estimated. So this inertia forces on the structure is one of the major effect on the. Next is the deformation of the structural members. Definitely because of this inertia force, the columns, beams, slab, etc., even the foundation, base shear, etc., all these things will come to the picture. And this deformation is make the structure more stress conditions, and the members, if they are not able to withstand these deformations, they start failure from one point. This may propagate to the other sides if the proper distribution of the moment and force is not happened in that particular structure. The failure may occur there. And if the failure is happened to the columns, definitely it will be a global failure. And the beam, if it is happened to the failure in the beams, maybe the local failure of that particular floor. So this may happen because of the deformation of the structural members. Horizontal and vertical shaking is the usual which we are appearing or experience during the earthquakes, where the vertical shaking will not be a big issue for the buildings because of the entire gravity of the structure is acting downward direction. So the vertical motion is compensated by its weight itself, but some cases, the design of bridges, where the vertical or the gravity force is comparatively less, the vertical directional earthquake force is also taken into consideration. Otherwise, majority of the infrastructure, especially building, we are considering the horizontal X and Y directional shaking and the related development of the shear forces and its design procedure, etc. Now, next is the Substory Effect. Substory Effect is due to the variation in the stiffness of the structure, I mean adjacent floors. This is a very common failure because the bottom floor is normally almost all multi-story building converted into car parking areas, where the stiffness of the column and the supporting wall is not there. So the stiffness variation will cause a sudden change in the variation. So that may cause this type of failure. The plastic hinges will be formed where the sudden change in the stiffness of the column members. And substory failure is a very common failure due to earthquake. This is explained about the short column effect. Short column effects always attracts more load, more lateral force because of its stiffness is comparatively higher. And the cross-section area, if it remains the same, as well as the material has also the same properties, reinforcement is also same. So there is a possibility of short column failure. So the second figure actually explained the column which is stiffened or the support is given in the lateral direction by the walls, but some area is leave for the ventilator purpose or the ventilation. So that area is failed because of the short column effect. Then lack of ductility or ductile detailing. We have a codal provisions in India where we have to give the ductile detailing in this manner. Unfortunately, that is not happened or that is not practice, good practice for many of the areas in India. So poor detailing and non-ductile behavior of the columns causes the failure of that members, including column as well as beam. In this case, we have to consider the non-structural damages as well, because non-structural damages are the brittle failure, brittle cracks sometimes. Most of the non-structural elements are brittle in nature, glass, brickwork, plastering, etc. So what is the issue is, once the non-structural failure is arised, and there is a more possibility to propagate the non-structural failure, which may finally end up with the structural failure. So we have to consider the material for the non-structural elements, so that it can also take part of its some elastic nature, so that the non-structural damages can be avoided. And these non-structural damages also lead to the structural and total failure of the structure. And the next is strong column weak beam philosophy, which is not a big issue for shear building. When we are considering the shear building, it is totally against the strong column weak beam. Actually, we need strong column and weak beam to avoid the global failure of the structure. But when we do the multi-degree freedom system and the shear building model, we consider the other way. That means the strong beam, weak column, so that the deformation that is happened to the columns and the beam as well as the floor will be rigid body motions. So that concept itself is a wrong understanding when we think about in the earthquake resistant design context. Founding effect is also a common issue. While the two different buildings having different structural dynamic properties, different time period, as well as different material properties, and based on the other parameters acting on the structure, the inherent nature of the two adjacent building, the ponding effect may occur. Very common failure in many of the earthquake failure history. Then we have the horizontal irregularity effect. Horizontal irregularity, we have geometrical level, mass level, as well as the stiffness level. So this horizontal irregularity will cause us a torsional effect on the structure. Torsion failure is a shear failure, catastrophic failure. So if you go for any kind of irregularity in the horizontal level, these are the typical figures given in the IS 1893. And this second figure is representing the failure of this irregularity as well as geometrical mass and stiffness irregularity causes failure of the structure. Next is the vertical irregularity, also very important. Again, the geometry, the mass, and the stiffness, which is causing the vertical level of irregularity, vertical torsion, as well as the failure of the structure. So vertical irregularity is a very common issue while we are discussing with the multi-storied building, especially for the staircase area. See the figure, actually the failure of a staircase area where the lift area where the stiffness is comparatively less which compared to other adjacent sides. Sometimes the water tank is also constructing above the staircase room, so the failure may occur in that region initially. So all these under the classification of the vertical irregularity in different ways. Then the discontinuous force resisting system. The left-hand side, it's a failure of a multi-storied building because of the different kinds of irregularity that is happened. But in the right-hand side, you can see the structure is very familiar. Its name is Antilia. It's the biggest residential complex in the world. The residence of Mr. Mukesh Ambani, the Reliance Group chairman. And when you go through the design parameters and the members mentioned here, each and every floor are different from the adjacent floors. If you go for a thought about substory effect, weak story effect, vertical irregularity, horizontal irregularity, everything is there. Still, the structure is safely withstand because the challenge of earthquake resistant design is coming from that point onwards. We cannot avoid some essential requirement or the desire of the architect or the client. So the structural engineer is under pressure, and a real structural engineer and a earthquake resistant designer must be capable of to understand the behavior of the structure, even though this kind of irregularities are there. So we have to take care about that issues. So the previous slide actually explained not to go for such type of construction, but you have to take care about the effects of these issues, and accordingly you have to design. In the design you have to consider all these factors. So this typical building itself is it's a proof that we don't have any limitations, because many of the structural engineers or sometimes the builders, they are sometimes asking about, if you are going for an earthquake resistant design, how we can make modern aesthetic appearances, etc. And the size of the column, orientation of the column, it should be always in the regular manner. Then how the building will be making an outstanding appearance from other building, etc. All these questions are a regular question from the client side or the architecture side. But the challenge that is, we can accommodate all these things considering the effects of these irregularities, and we have to take that part also in the design. That challenge is the modern earthquake resistant design where we can adopt. See, in another building, these photographs are taken from internet. Simply I Googled all these things, you will get all these. Again, the horizontal, vertical, mass, geometry, stiffness, everything is under an irregular manner. Mentioned that there are around 354 individual apartment units. See how they constructed this building, full of irregularities. And if you can construct this particular irregular building in an earthquake prone area, that is actually the challenges of earthquake resistant designers. We can accommodate all these things under, maybe it will be a costly affair, and the analysis is also required costly. However, we can make this, and this is also possible. Nothing is impossible for. And another area where Dr. Shah is also interacted with you about the soil structure interaction. It's a combination, this combined area where the structural engineers and geotechnical engineers together work on it. As we know, the intrusion of water through the soil, where when it is a sandy soil, the intrusion of water, and also the entire sand particles will be suspended because of the intrusion of water. The complete shear stress, shear forces, and the shear strength of the foundation will lose. The entire building will fail only due to the foundation failure. Maybe the superstructure there is no issue. It will fall down, overturn because of the foundation failure. So this is an important area where the structural engineers come up with geotechnical engineers and work against the effects of earthquake. That is also a major area which we have to consider for the effects of earthquakes on the structures. So that two parts are over. I think it is the time to make a small discussion if you want. The third portion is the precautions which we can adopt along with the earthquake resistant design. The first two parts is an awareness about the structural engineers, those who are interested in earthquake resistant design, a complete awareness about these are the issues, these are the causes, etc. Then we have to think about the from the failure history sometimes. Based on the failure details available in the previous history may helpful to make the precautions of the earthquake. If required, we can make a small discussion. Otherwise, we'll continue this portion also. What about the participants? Now we almost 45 minutes over. Any discussion is required from the participant side? Dr. Abhilasha?
Pardon, sir?
Yeah, any discussion is required at this point time?
No, sir.
Yeah, okay. So let us continue. The precautions of earthquake effects. So the two portions or the major areas which we covered is to understand the behavior and the reason for earthquake and the causes of earthquake, etc. Now let us think about the precautions, how we can overcome the earthquake effects. Actually, this is a very interesting photograph. Sakhalin Island, which is one of the biggest islands of Russia, where they identified that there are around 19 faults, an 800-kilometer length oil pipeline. There is no other option for them to make a movement of oil or gas through this line. And frequently happening earthquakes made a decision to them. See, the pipeline is undergone. It is allowing the movement of the earth, and it is accommodated the lateral movement of the pipeline through wheels. So this is the way how we are considering the earthquakes and how to overcome the earthquake effect. As you know, we cannot stop or we cannot prevent the earthquake, but we can accommodate the earthquake effects in this way. If an earthquake happened in this region, the pipeline itself is allowing to move both sides, and the failure or the cracks will not be there. So this is the way we have to. This is actually a interesting figure or photograph where how we can approach an earthquake resistant design. That means how we can accommodate an earthquake force on the structure and how we can overcome that issue. This is the way we are thinking. The thought process will be in this direction. For that, we have to make a proper understanding about the dynamics. Dr. G.P. Somasundaram sir is explained about the dynamics in the previous sessions. Because earthquake force is a random vibration or dynamic force randomly acting on the structure, we have to understand the basic difference between the static and the dynamic loading. And these are the expressions for static and dynamic, where the inertia force is also coming into the picture along with the static equilibrium, so that we can convert that one into earthquake force, even though there is no force acting on the structure. Because of the movement of the foundation, inertia forces will be generated, and that will act as an external force. This is what is happened to earthquake forces. These are the expressions which we can estimate. And the idealization for the multi-story building is also possible. We can analyze the multi-story building by shear building concept, even though the shear building concept is against the earthquake resistant design philosophy. But to understand the behavior of the structure, multi-story building and a multi-degree freedom system, which is idealized in this way, we have mathematically models of the same can be estimated. And we have to understand the generation of this, the normal force and earthquake force, how it is varying. And the inertia force is, as I told you, the inertia force is also associated with the earthquake force. Energy dissipation is there. So multi-directional and unpredictable time, etc. That is also what is called the random nature. Now, these are the representation of the P ground acceleration, P ground velocity, and P ground displacement. These are the parameters which we are considering for the design for the earthquake resistant building. which is a derivative of time derivative. So that is the first Fourier series and the reverse first Fourier series in mathematical level. We can understand the different parameters and properties of this. Concept of energy storage and energy dissipation is the basic idea behind earthquake resistant design. So the nonlinear level of deformation and the ductile nature, etc., or explained under the concept of energy stored and energy dissipation. The backbone of earthquake resistant design is under the nonlinear deformation and the concept of energy storage and energy dissipation conditions. So this understanding is helpful to an earthquake resistant design for the structural engineers. How ductile nature within the limit, because even though if you are applying the ductile nature or we are imparting the ductile nature to the structure, it has some limitations as per the proportions. So if you can ensure the ductile nature, then 50% of the problem is solved. In order to get an idea about the ductile nature, behavior, etc., the concept of energy stored and energy dissipation should be there in your mind. Then the response reduction factor is another design philosophy, design aspects of earthquake resistant design. Because of the ductility, redundancy, as well as the overstrength, we have to consider all these resistance against this. Now, when you consider the energy dissipation as well as the concept of response reduction factor, this will be helpful for a designer to make an understanding and to make an earthquake resistant design effort. Response reduction factor can be estimated by this way. I'm not explaining the word by word and figure by figure of these slides. As I told you, these old slides will be shared to you. So you can go through it and just giving you an idea about the presentation, and in detail, you can go through the slides later. Okay. Now, these are the basic analysis in earthquake resistant design: static linear, static nonlinear, static dynamic linear, and a dynamic nonlinear analysis. In which the static linear analysis is one of the simplest and easiest and less time consuming analysis, where we will consider the effects of dynamic equivalent or equivalent static. We will carry out the static analysis, and equivalent to the dynamic analysis will take the values. So this is one of the simplest method which we practice in our academics. Then static nonlinear analysis is actually a review about the performance of the structure. Pushover analysis is generally known as. This is also possible through only reliable softwares. The nonlinear analysis itself is not a practically possible analysis by manually. But even though pushover analysis is considered as one of the strong analysis procedure to understand the behavior of the structure in different situations. Then the dynamic linear analysis is one of the most popular analysis in the earthquake resistant design, with the help of the reliable softwares. Response spectrum and the codal provisions in India, IS 1893 is also recommending the response spectrum analysis, dynamic analysis, but in the linear level. And the so-called realistic analysis is known as the dynamic nonlinear analysis, that is time history analysis. Even though it is a very time consuming as well as
Sir. I think there's some network issue.
Excuse me, sir. I think there is some network issue. So you're muted. Sir. You're muted. Please unmute you. Participants, I think there is some network issue. Please wait.
Yeah, okay. Yeah,
Yes,
am
sir.
I audible now?
Yes, sir, you are audible.
Yeah, I think that is some issues that is happened in between. Anyway, let me share the slide once again. Yeah, is it visible now?
Yes, sir.
Yeah, okay. So we are talking about the different types of analysis, and one of the simplest analysis is the nonlinear, equivalent static analysis. These are the expressions given in the IS code. In PG level, we have a theoretical and physically we are doing the analysis. We can do it without much difficulties. Now, response spectrum analysis is also very popular. Most of the professional structural earthquake resistant design, they use the response spectrum analysis. These are the spectrums available in the Indian code, where the response spectrum analysis is considered as the static dynamic analysis, comparatively less time consuming, and we are getting an overall idea about the performance of the structure. The linear level analysis, then we have, if it is a building, we have the mode shapes. Then the texture analysis is only the effect and the energy dissipation and the all the potential areas of the material as well as the members is taken into consideration, and we have this. Earthquake resistant design philosophy also you have to keep it in your mind. For minor earthquakes, that we assuming that minor earthquakes may occur frequently. Moderate earthquakes, maybe that will occasionally it will occur. Rarely occurring earthquakes are considered as a strong shaking. So when we go for an earthquake resistant design, the building must, performance of the building must be according to the requirement. So if you are going for a strong shaking earthquake, strong earthquakes and design is only for the purpose of the strong earthquakes, maybe it will not occur during the, as per the requirement, if you can ensure the performance of the structure. That is what is called earthquake resistant design philosophy, where for the minor earthquake only the non-structural damages may occur there. For major earthquake, maybe the structural damages will be there, but it can be repairable. For severe earthquake, the entire structural failure may occur, but even though the total collapse will be resisted. So in these aspects, if you go for the earthquake resistant design, then only it will be an acceptable design and it will be economical design. So that part also should be there in our mind. Then only we can survive for the requirement of the industry. So these are the basic design philosophy and the design principles of earthquake resistant design while we are applying the earthquake. Now the different methods, if you go for in a very broad manner, the one of the best method is to avoid the seismic affinity design practices. That means, first of all, if you are removing the irregular nature and irregularities, we can avoid the vulnerability of the structure against the earthquake. So that is the best method, so that the effect and effect will be less. Then the ductile behavior, this is actually the role of a structural engineer. We have to make an inherent ductile behavior of the structural member internally or externally. This is the area where the structural engineer can make many pockets to work on it. And we can apply externally the base isolation and seismic dampers. These are the additional features that we can adopt for the newly constructed building, and especially for already constructed building. If you want to improve the structural behavior and earthquake resistant capacity of a structure, we can go for the seismic dampers. Base isolation can be adopted for in the beginning of the structural builds. So these are the basic methods, only a broad area which I am talking now, where we can ensure the building will effectively against work on the effects of earthquakes. This is the photographs of base isolation. Almost all of you are aware about these things. The propagation of the ground movement to the superstructure will be shortened by this base isolation. It is isolated from the movement, so the effect will be less. And the dampers, viscous dampers are the popular dampers. There are many other dampers are also available, liquid dampers, etc., which is already discussed. Any kind of dampers will also provide the ductile nature of the structure in a global level, sometimes in the member level. So the ductility, if you are providing to the structural failure may reduce, and also it can withstand by dissipating energy which is coming through the external forces like earthquakes. Now the masonry building is another major area. Approximately more than 80% of the building constructions in India are masonry constructions. That is the reason why many areas, many institutions, they are concentrated on the masonry buildings. There are many methods explained in different ways, and there are some proven records are also horizontal and vertical bands. That is reinforced masonry work. That is the general terminology for that. And these areas where we can withstand the earthquake resistant building in a very effective manner. These areas are also there for this. These are some of the building configurations which we causes the issues related to the structural damages. Building configurations which is mentioned in the left hand column, basically that they are the common things, and the issues are also mentioned in the structural problem column, that is the middle column, and the remedial measures are also measured. I'm not going to in detail, as I told you, these slides will be shared to you. You can go through it. It's very directly, it is mentioned everything. Now, apart from all these things, there are many innovative ideas for the structural design. So first of all, we can go for the innovative material and the different structural system and different structural design procedure, capacity design, performance-based design, etc. already discussed with you. All these things are the innovative methods. At the same time, it will not affect the required aesthetic visions and desire of the client. So as I told you, just like Antilia, the structure where we have very irregularity, very much irregularities are there, even though the structure is designed based on these basic principles, innovative methods, and etc. All this can be utilized for. This is another innovative idea which is constructed in Japan, Nomi, the place. These are the curtain cables. They are provided with the anchoring of these cables. They are the thermoplastic carbon composite thread. Exterior part of the structure, they provided the same similar things in the interior areas also, wherever it is anchored to the floor. So due to the movement of the earth, the movement of the building will be restricted by this kind of anchored cables, curtain cables. So these type of innovative ideas are also provided in many of the cases to make a aesthetic. Now there is a mobile app which is developed by Dr. Raghu Khan as part of his research work in IIT Bangalore, and currently he is working as a professor in IIT Madras. In India, there was a project initiated by the Prime Minister to identify the locations of the major faults. Seismic Hazards of India. You can download this app in your mobile, and the place where you want to make some construction, and if you want to make any analysis of that earthquake resistant design, you will get the details about the faults, the occurrences, its depth, etc. Everything is available in your fingertips. In that way also, the scientific community is upgraded to work on against the earthquake effects. So this is the Seismic Hazards of India is one of the popular mobile app where we can make use of the different faults and its location in India. And the mission is completed, and the mobile app is released to general public without any cost. So that is also possible to overcome the effects. Now let me conclude my sessions. This is my professor. You are familiar with Dr. T.P. Somasundaran sir. He was my guide during my PhD work at NIT Calicut. Now, for the time being, let me conclude my discussions. You can make use of this time for the further discussions. Thank you very much. Professor Nisha.
Thank you so much, sir. The session was very informative. Now, the forum is open for discussion. Participants can either type their queries in chat box or unmute yourself and ask questions. If you have any queries, please type in the chat box or you can ask by unmuting yourself.
I think we are discussing about very superficial level of discussions. Nothing is new for them. Just we made a refreshment from the knowledge which they have already. However, if you want anything else to discuss in my level, the limited level of knowledge, I can also share my ideas.
Okay, thank you, sir.
Okay.
Now we will have a lunch break. Please rejoin at 2 o'clock. We'll have the valedictory function and feedback sessions at 2 p.m. in the afternoon. You can share your feedback We would love to hear from you all. Also, all of you, please don't forget to submit final feedback and test link that would be shared after our validatory function. We shall have a group photo too at the end of our validatory function. Thank you. We leave for lunch break and please rejoin at 2 p.m.
Good afternoon to one and all, respected dignitaries, colleagues, and my dear participants. Welcome you all to the valedictory function of AICTE Atal funded FDP on recent advances in earthquake engineering, organized by Department of Civil Engineering, Vidya Academy of Science and Technology, Thrissur, Kerala. Let's start our function with a prayer. I welcome our dear students, Ms. Anjali S. Nair and Ms. Anjana P. Anil for prayer.
Sankarchatvam Samvadatvam Sambhumanamsi Janata Deva Bhagam Yatha Purve Sanjanana Upasate Samaliva Kuti Samana Hridayanika Samanamo Mastu Mano Yatha Maha Susahasati.
Thank you so much, my dear students. Now, let me invite Mrs. Nisha Varghese, Assistant Professor, Department of Civil Engineering, Vidya Academy of Science and Technology, for welcome address. Ma'am, please.
Good afternoon, respected President of the function, Dr. V.N. Krishnachandran, Vice Principal and HOD, MCA, Vidya Academy of Science and Technology, Dr. Saji C.P., Principal, Vidya Academy of Science and Technology, Dr. Sudha Balagopalan, Dean Academics, Vidya Academy of Science and Technology, Mr. Suresh Lal, Executive Director, Vidya International Charitable Trust, Mr. P.N. Uniraju, Administrative Director, Vidya International Charitable Trust, Dr. Justin Jose, Head of Department, Civil Engineering, VAST, Dr. Abhilashna P.S., Associate Professor, Civil Engineering Department, Vidya Academy of Science and Technology, all resource persons and participants of this gathering. Good afternoon to all of you. First of all, I welcome Dr. V.N. Krishnachandran, Vice Principal and Head of Department, MCA, Vidya Academy of Science and Technology. Our institution is committed to conduct these type of programs for the technical development of faculty. Krishnachandran sir was instrumental in conducting this program. Once again, I welcome you, sir, to this function. Next, I welcome Dr. Saji C.B., Principal, Vidya Academy of Science and Technology. He had extended constant motivation and support for conducting this FDP. I welcome you, sir, to this function. Next, I take the pleasure of welcoming Mr. Suresh Lal, Academic Director, Vidya International Charitable Trust, to this function. Motivation and support extended by him for the conduct of this program was exemplary. Once again, I warmly welcome Mr. Suresh Lal to this function. Next, I take privilege of welcoming Mr. Unirajan, IPS, Administrative Director, Vidya International Charitable Trust, to this function. Today, we are fortunate to have an eminent personality like him to grace this occasion. Once again, I welcome you, sir.
Thank you.
Next, I welcome Dr. Sudha Balagopalan, Dean Academics, Vidya Academy of Science and Technology, to this function. Dr. Sudha ma'am is our role model and inspiration to organize this function. I welcome you, ma'am, to this function.
Thank you, Blasha.
Next, I welcome the coordinator of this program, Dr. Justin Josie, Professor and Head of Civil Engineering Department, Vidya Academy of Science and Technology. He was the backbone in guiding and motivating us in all ways. I take pleasure in welcoming you, sir. Next, I welcome Dr. Abhilasha PS, Associate Professor, C Department, and co-coordinator of this program. The program was materialized by the diligent effort of her. I welcome you to this program. Finally, I welcome all resource persons and participants and fellow faculty members to this function. Thank you.
Thank you so much, ma'am. Now I invite Dr. B.M. Krishnachandran, Vice Principal and HOD MCA, Vidya Academy of Science and Technology, to deliver the presidential address. Sir, please.
Okay. Good afternoon, all of you. The respected directors, Mr. Suresh Lal, Executive Director of EICT, Mr. Unirajan, IPS retired. I'm sorry. I'm really sorry. ഒരു മിനിറ്റ് ഞാൻ ഒരു പ്രോഗ്രാമിലാണ് കേട്ടോ. We'll talk later. I'm really sorry. Respected directors, Mr. Suresh Lal, the Executive Director, Mr. P. Unirajan, IPS retired, who is the Director Administration of Vidya International Charitable Trust, Dr. Sudha Balagopalan, Dean Academics, Dr. Justin Jose, Head of the Civil Engineering Department and the coordinator of this 5-day faculty development program, Dr. Abhilasha, Ms. Nisha Varghese, the valued participants for the workshop, and the resource persons, and all others have joined us in this program. Today, the college principal, Dr. Saji, is fully occupied with some other programs, which he is not in a position to exempt himself from. And so he asked me to preside over this function. So, and thanking him for giving me an opportunity for this, and also thanking the organizers for allowing me to take this responsibility. Thank you. So the 5 days program, 5 days of faculty, 5 day long faculty development program has nearly concluded, and we are having the valedictory function. The faculty development program can be called a success, is in my view, if that results in really in some academic development of participants. If the participants feel they learn something, even in mathematical terms, we say epsilon, even if it is very small. If you have learned something new, which results in the academic development, and then the FDP is a success. So by that yardstick, and considering the stature and the academic credentials of the research persons, I am fully sure that all the participants have learned much than this small quantity. So I believe that the 5-day faculty development program was a great success. And I was inquiring about the number of participants in the various sessions. And I was told that there was a remarkably good number of participants. So the absence was very rare. It's an indication of the quality of the various sessions. So I would congratulate the organizers, especially the coordinators, for bringing together such a large number of academic luminaries or specialists in this particular area, the earthquake engineering, and to talk to participants about their expertise and to illuminate the various concepts, youthful academic. So I think I should congratulate you, the participants, for making use of this opportunity offered by the Academy of Science and Technology to give you a window of an opportunity to develop yourself again. So congratulations to participants, and also congratulations to the organizers. I'm sorry in one aspect. The other aspect is that the program was conducted in the online mode. Of course, because it is because of that, sometimes the number of participants was higher. But actually that, we have to miss the opportunity of providing the hospitality of the institution. You could not enjoy the great hospitality that could have provided you if you have come here. How Vidya is different. The ambience, the people, the students, the faculty members, how they are. And that hospitality and the academic ambience of the institution was not something which would not end. I'm really sorry about that. Okay. Anyhow, the program is over. Now, as mentioned at the time of the inaugural ceremony, this institution is managed by, I could say, a very genuine trust. Trust means it's a trust with more than 1,000 members, all of whom are non-residents, non-resident Indians, non-resident Keralites. And it was instituted without any desire for a profit. The motivation was clearly service. And because of that, the management is keen to see that everything that is done here is the highest standards. In particular, say such activities like faculty development programs and others are conducted at the highest possible standards. So why I am saying this at this juncture is that we will be looking forward to your feedback. See, when I have organized similar programs earlier, I used to say, give your feedback in a very genuine manner. Whatever you feel, express it freely, because that will give the institution, that give the organizers, and also the future organizers of such programs here. See, the deficiencies in the service that we provide, some of the little things that you have missed, so that we can improve upon this. We can continuously improve the quality of service that you are providing. So there is one request to the participants. Of course, there will be a formal feedback taken by the authorities, by the organizers, and that feedback has to be submitted to the ICT. So in addition to that, I would suggest that you give your frank feedback, maybe in writing sometimes, or I think there is a feedback session after this. You can talk freely, fearlessly, and say that something was not up to your expectations or something which have been better. I hope it will not be taken as a criticism. It will be a constructive criticism for us. And all these ideas will be taken, will be considered when the institution organizes such programs in the future. We are looking forward to such valuable inputs from the participants. Okay, with these words, I conclude, and I hope the participants will have some pleasant memories of all the academic sessions that we have gone through here, and we'll be keeping in touch with your coordinators. Again, as I mentioned at the inaugural ceremony, I'm looking forward to this institution becoming a center of research in these areas. In say, okay, wish you all good luck and wish you happy learning back at home and at work. Okay, thank you. Thank you.
Thank you so much, sir. Now I invite Dr. C. Justin Jose, HOD, Department of Civil Engineering, Vidya Academy of Science and Technology, and coordinator of this adult FDP, to present the report of the FDP. Sir, please.
Okay, thank you, Ms. Ardra. Am I audible?
Yes, sir.
Okay, respected directors of the trust, our vice principal, dear participants, and my dear fellow colleagues, and respected resource persons, good afternoon to one and all. Recent advances in earthquake engineering is a sponsored faculty development program from AICT Training and Learning Scheme, which is successfully conducted at Vidya Academy of Science and Technology by the Department of Civil Engineering, with around 100 registered participants and 14 numbers of resource persons from different parts of India. The 5-day program was scheduled to conduct from 6th December 2021 to 10th December 2021, that is today. The inaugural function was happened on 6th December 2021, Monday. The coordinators, Dr. C. Justin Jose and Dr. Abhilasha P.S., coordinated the program with the other delegates. Dr. Katta Venkat Ramana, Professor, Civil Engineering Department, NIT Karnataka, handled the first session on the topic Engineering, Seismology and Learning from Past Earthquake. The session was very well accepted and audience really benefited from the fruitful thoughts and explanations of Dr. Katta Venkataraman. The second session and third sessions were handled by Dr. KBM Namboodiripad, former professor of NIT Calicut, Kerala, on the topic vibration of continuous system and practical vibration problem respectively. He discussed very well about all the vibratory systems and techniques to vibration isolations. Participants had a very vibrant discussions after the session. On 7th December 2021, Tuesday, the first session was handled by Dr. Ajay C., Senior Principal Scientist, Central Building Research Institute, Roorkee, on the topic Earthquake Safety in India. The session was very informative and he explained about the vulnerability of the building stock in India and tools to sensitize and about the issues connecting preparatory arrangements and measurements for earthquakes. Dr. Kavita PE, Associate Professor, Civil Engineering Department, Federal Institute of Science and Technology, Ankamali, handled the second session on the topic Significance of Soil Structure Interaction Analysis. She was successful in delivering soil structure interaction and the participants had a very vibrant discussion after the session. The influence and the behavior of soil as well as the response of pile foundations under the loading was major discussion about the session. Dr. T.B. Somasundaran, Professor, NIT Calicut, delivered the third session on the topic Dynamic Responses of Structures for Seismic Forces. Basic principles of structural dynamics were presented with emphasis on application on the earthquake resistant design of building structures. Dynamic characteristics, the response of these systems to harmonic and impulse loading were described and illustrated by the application to simple structures. On 8th December 2021, Wednesday, Dr. Rohan Bhaskar, Senior Project Officer, National Center for Safety of Heritage Structures, IIT Madras, handled the first session on the topic Recent Advances in Seismic Fragility and Vulnerability Modeling. The session was very well accepted by the participants and he covered a lot of portions which was useful for PG and the PhD scholars. Dr. Deepa Balakrishnan, Professor, Civil Engineering Department, School of Engineering, Kochi University of Science and Technology, Kerala, handled the second session on the topic Earthquake Resistant Construction Techniques. She was successful in delivering all the major earthquake resistant techniques to the participants. Participants had a very vibrant discussion after the session. Dr. Sajid A.S., Associate Professor, NIT Calicut, handled the third session on the topic Salient Features of Recent Earthquake Codes and Design of Special Structures. He explained to the participants the design of water tank, chimney, retaining wall in a beautiful manner and also had a detailed discussion on the salient features of earthquake codes for the design and ductile detail. On 9th December 2021, Thursday, Dr. Bharati Raj, Assistant Professor, Civil Engineering Department, NSS College of Engineering, Palakkad, handled the first session on the topic Application of Smart Concrete in Seismic Damage Detection. The session was very much helpful for the PG students and the PhD scholars to gain knowledge about the self-sensing concrete. She explained how self-sensing concrete can be applied for seismic damages detection. Dr. Robin Davies, Assistant Professor, Civil Engineering Department, NIT Calicut, Kerala, handled the second section on the topic Performance-Based Earthquake Analysis and Design. He was successful in delivering the performance-based seismic design of structures and the participants had a good interactive session after the session. Dr. Smita KK, Associate Professor, Civil Engineering Department, Stockage Institute of Science and Technology, delivered the third session on the topic finite element analysis of buildings subjected to earthquake loading. The basic principles of finite element analysis of building subjected to seismic loading were very well explained. On 10th December 2021, today, Dr. Zaid Jalaluddin Shah, Professor and Head, MES Engineering College, Kuttipuram, handled the first session on the earthquake-resistant design of foundations. He explained about liquefaction, slope stability, landslide, etc. in connection with the earthquake and discussed about the mitigation activities. The second session was handled by Dr. C. Justin Jose, Professor and Head, Department of Civil Engineering with the Academy of Science and Technology. Actually, it was a concluding session and delivered the reasons, effects, and precautionary activities of earthquake in general. This is a brief report about the entire program, the 5-day faculty development program organized by Department of Civil Engineering with the Academy of Science and Technology under the sponsorship of ATA. Thank you very much.
Thank you so much, sir. Now, I invite Mr. Suresh Lal, Executive Director, Vidya International Charitable Trust, for delivering the felicitation speech. Sir, please.
Thank you. Respected dignitaries, dear participants, and my dear Vidya family members, a good afternoon to you. First, I would like to congratulate the Civil Engineering Department for successfully completing the AICT adult-sponsored online faculty development program on recent advances in earthquake engineering. HOD and the staff members deserve a special mention on this. The technology is changing the way we do things, and it is vital to keep abreast of the latest development in the industry. During the past 5 days, the experts in various fields have discussed new developments in the industry, which I hope have given the participants an opportunity to enhance their performance and advance in their career. The engineering education industry is going through a challenging period. This year's trend in admission shows that even civil engineering is losing its field. Therefore, a concerted effort is needed to regenerate interest in engineering education. I hope the lectures and expert talks have given you enough ammunition to face the challenges and bring back the lost glory of civil engineering education. Thank you.
Sir?
Yeah, I'm done. Thank you.
Okay, thank you so much, sir. Now, I welcome Mr. P.N. Unirajan, Administrative Director, Vidya International Charitable Trust, for delivering the felicitation speech. Sir, please.
Thank you, ma'am. Then respected Vice Principal Dr. V.R. Krishnachandran, who is the chair of the function. Mrs. Nisha Varghese, who gave us a hearty welcome address, like a seat and some welcome drink. Respected Dr. C. Justin Jose, the sincere and committed attitude of the Department of Civil Engineering. respected to the Executive Director, Sri Suresh Lal sir, respected to Dean of Academics, Dr. Sudhama, and Dr. Abhilasha ma'am, who is here to give us a good vote of thanks, and my dear children and the other respected dignitaries and participants who is attending the program. First of all, I like to congratulate the whole team who organized the program. From the name of the program itself, that is the Faculty Development Program, it is clear that the program is aimed to develop or improve the quality and expertise of the faculties. The subject chosen for the program is the recent advances in ethical engineering. That is also very good. That is also an apt subject, especially in this present scenario. We have seen the collapse of Latur village in 1993 in Maharashtra state, in which around 10,000 people died and 30,000 or more than that got injured. The total damage that caused during that earthquake was estimated as more than $1,500. 1,500 crores dollars. I mean $1.5 billion. Now we are also here experiencing earthquakes in Trichur districts also, very nearby to our places, adjacent to our places in Tali and Valley. The design for the architecture, design and expertise of Larry Becker became very popular because it is he who had constructed a building in the post-earthquake area in Latur. I think that everyone is known, and he also became very popular because of his construction, the low-cost construction, as well as the design adopted by him, with which it is stated that then we can overcome the earthquakes. It is stated so. I like to repeat the sentence of our vice principal, that is, the management is desirous of giving the best to the children, and for that to give the best to the teaching staff also. As we can say that only if we give the best input to the faculties, only then we will get the best output from them in the form of best students. No doubt in it. So, in the present scenario in Kerala also, I think that then we are having tens of dams in Kerala. Especially then we are all afraid of the dam known as Mullaperiyar Dam, more than 100 years old. Then it is said that if an earthquake happens there in that area, the dam may collapse, it may come down, which may, no doubt in it, I think that may cause a catastrophe maybe. I like to use that word, especially in the districts of Idukki, Kottayam and Ernakulam. So I think that this is a very good step taken by the Civil Engineering Department to arrange this program, with which I think that the faculties might have been expertised. In police, usually we are saying or telling that then what is the need of training, then what can make you improve your expertise, improve your quality, improve your experience. Then we will tell that the first is the first sentence or first word we can use is training. Then what is the second word? Then also we will tell that the second word is also training. Then there is a third word. Then what is it? Then also we will tell that it is training. Likewise, by imparting trainings or faculty development programs to the faculties, we are improving the quality of the standard of the experience and the expertise of the faculties, to see that they are giving the best training, best coaching or education to the children. That no knowledge is information, and the information that they gathered, from these programs can be imparted or given to the children, with which the children will also be benefited. And I hope that the other departments also follow the suit. And again, I use this opportunity to admire the organizers of this institution, especially the HOD, Sri Justin Jose, Dr. Sri Justin Jose. And I wish all the best. And I hope that then we will, I think that I have spoken to Abhilasha Miss, so that we can have a short report from the faculties, how they benefited, so that it can also be utilized in another occasion also. Then again, I wish all the best and thank you. And thank you for inviting me to this program also. Thanks a lot. Thank you.
Thank you so much, sir. Now I invite Dr. Sudha Balagopal, Dean Academics, Vidya Academy of Science and Technology, for delivering the felicitation speech. Ma'am.
Thank you, Ms. Adra. A very good afternoon to everyone, which includes our respected, the respected President of this occasion and our Vice Principal, Dr. V. N. Krishnachandran, sir, as also our Director Duo, who actually addressed you and told you about the importance that such programs have for the institution. The very respected the respected head of the Department of Civil Engineering, who is coordinating not just the FDP, but the entire program of a very effective department, which is our Civil Engineering Department. The ample support given by all his faculty members and staff members, especially Professor Abhilasha, who is also the coordinator. Then again, the very respected distinguished resource persons, which includes our own friend, philosopher and guide, Dr. K.B.M. Nambudripat sir, the very eminent participants from different parts of the country. Let me also add not just my good afternoon, but also my congratulations to the department for having organized such a program with such a topic at such a time, especially because the seismic map of India is changing, perhaps of the entire world is changing, as you must have got to know during the faculty development program. And if it is changing, we should be the persons who should equip the students to see everything from a different pair of eyes. And I hope that in this context, the faculty development program was a success. In fact, the last 3 days, I was also attending a similar program. Thankfully, I could attend the first day's program, but later on I had to attend another kind of faculty development program, again given by All India Council for Technical Education. It was conducted by National Institute of Disaster Management. So the first day of this faculty development program, which I attended, prepared me sufficiently to listen to all the respected speakers who were speaking in the other faculty development program. And what I noticed was that lots of multidisciplinary kind of knowledge is required to address the problem, to even think about the problem, to even conceive solutions and also make them implementable. And as the president of the occasion, as also our vice principal was talking about, it should be there should be an outcome. Of course, the concept was well received. That could be the reason why we got this faculty development program approved, and it was well implemented, as could be seen from the different segments of the faculty development program. Now, assessment might come in a particular manner, which is called as the feedback, but of course I suppose you give the feedback directly to the Atal program, as is the pattern, but then thereafter should appear the outcome of the program. And I was lucky to talk. In fact, Professor Nisha called me as a role model. So let me try to speak a few lines along this context also. In fact, last evening I was talking to the very young students of our college, which happens to be the first year students of our civil engineering department, essentially civil engineering department. In fact, I tried to tell them that they should start doing things on their own, because that is the best kind of pedagogy. That's the best kind of teaching learning practice. And since now we have an issue before us, we have the different kinds of disasters that are happening in different parts of at least our country. And the disaster is headed by, of course, none other than the earthquake, because earthquake gives rise to even fire, it gives rise to tsunami, and it gives rise to many different issues. Loss of life, as was just now talked about by our administrative director. So definitely we need to impress upon the students that they have to start thinking, and no other way is better than making them do projects. In fact, I have told them, in fact, even last evening, I was telling them that there are at least 12 kinds of vulnerabilities in buildings. And these vulnerabilities come about as a result of perhaps non-standard kind of designs being implemented. I noticed something else during the talks that I listened to in the National Institute of Disaster Management. They were the spectrogram that was relied upon for mapping the seismics, etc., seismic map, etc. It seems that they were using the spectrogram, and there are research papers which say that there should be other kinds of techniques which might change the code altogether, because the codes that are right now are dependent upon spectrogram. So digital signal processing, which will improve as the years go by, will have a big role to play in perhaps designing the codes, etc. Which means that you civil engineering teachers are going to be very important people to see that lives are not lost. So why don't we impress these things upon our children? And that is what we are trying to do. And I definitely do require the help of the entire community from at least our college, that is the civil engineering department. And so I'm requesting them here itself to see to it that we try to do some models, because we try to build up some models. It may not be them, they may not be, it may not have too much of accuracy, but then it will give rise to thought. It will give rise to thoughts in the minds of young people, and they'll be talking to others. So we have to do a lot of talking, thinking, as also listening to people, and then implementing. And finally, that kind of knowledge needs to be all pervasive. And perhaps we'll get some not just faculty development programs of this kind, but also other seminars and colloquium, etc., wherein we should discuss this very important aspect of disaster management, wherein earthquakes do have a very important role to play, especially in the context of changing seismic maps as it is there. So today we are so perhaps in the civil engineering department, with the help of the HOD, all the faculty members who attend this program and who could not attend the program, together trying to help our students, the first year students, to model a few vulnerabilities, such that these vulnerabilities, the common people, whoever sees these models, will be able to realize that, okay, this kind of vulnerability is in our house or in this particular structure, and perhaps we'll go for solutions. The solutions are also there, of course. I think you had a session on retrofitting, you might have had a session on rehabilitation, you might have a session on repair also, like grouting, etc. Let me hope that the faculty development program has given room for given more space in your minds, in your thoughts, for addressing such issues, because in this context, in the infrastructure context, there is none other than civil engineers who have a role to play and who also take the blame. So I hope I have not talked too much, but my enthusiasm is unabated, and I wish that that the models that the first year students will set up here will be interesting to teachers who have joined us from everywhere, and you will also contribute, at least by viewing some of the bites that we may put up. That is some videos that we may put up once the models are ready. So I again thank the organizers for inviting me to offer my felicitations, and with a very huge heart and congratulatory note, I offer all my felicitations for this program, and thank you. Thank you.
Thank you so much, ma'am. Now it's the time for feedback by participants. We'd love to hear from you. I invite participants to share your feedback about our faculty development program. Participants, please. You can unmute and switch on your video and share your experience.
Good evening, everyone. Myself, Arya. This was my very first time experiencing an FDP, and that too with really very well-known dignitaries out there. All the sessions were really amazing and useful. Each speakers provided at least a new knowledge, so we new young ones can prepare further for future. I really should admire the pillars behind this program. It was very well coordinated by the team, Dr. Justin Jose, Dr. Abhilasha, and all other faculty members. It was really amazing. You bring out this really very well. I appreciate your hard work in making this a huge success. Looking for more programs like this, and I'm eager to attend that more. Thank you all. Thank you so much.
Thank you so much, Ms. Arya, for your valuable feedback. Anyone else? Participants?
Hello, ma'am. Am I audible?
Yes, ma'am.
Hi, this is Shiva. I'm from Chennai. Okay, so I thank the coordinators first for such a wonderful FTP. It was a very good experience. All the resource person are very good. Their information were, all the session were very informative, and it was really very useful for us. I thank, especially I thank Abhilasha ma'am, because each and every query, any doubt, she was answering it, she was responding for it immediately. Thank you so much. The FDP was too good, and there was no glitcher, and the network was very good because I have attended many FTPs before, the same Atal FTPs, but somehow there will be some network problem, or sometimes the audio video will be not there. But here we didn't face any of those glitches. Okay, so it was very nice and very so we'll expect more FTPs from your side. Thank you, ma'am. Thank you all.
Thank you so much, ma'am. Participants, anyone else to share your experience?
Am I audible?
Yes, sir.
Very good afternoon to one and all. Hello.
Good afternoon, sir. You are audible.
Audible. Yes, I am Vivekanandan, working as a scientist in Central Water and Power Research Station, which is one of the R&D institute of Ministry of Jal Shakti. So first of all, I thank the organizers for giving me opportunity to participate in the Atal FTP program on recent advance in the earthquake engineering. First of all, congratulate the entire organizing team and Professor Abhilasha for conducting the webinar in such a nice way, and even the COVID pandemic situation. All of us know that it is a very difficult task to connect all the people, all the resources from various parts of the country. Even the pandemic situation is a very big task. That was nicely carried out by Dr. Professor Abhilasha and to conduct the program in fantastic manner. Regarding the training, so almost all the technical sessions are nicely presented by the subject experts in various subdivisions of earthquake engineering. That is quite a mixture of good and moderate, excellent presentations delivered by the various experts. So in a nutshell, the training program, it is given the capsule of the advances in the earthquake engineering in simple way and simplest way and easy to understand. And we can carry forward with these ideas and concepts delivered by the experts in the training program. In our future research, I hope it will be very much useful that. Regarding network connectivity, as one of the presenters earlier told that participants, it is very fantastic. Really, we got into the network without a distraction or disruption. During the entire 5-day training program, it was all the queries raised by the participants raised immediately shuttered out by the organizing team and provide the assistance from time to time to resolve the issues and take care of the participants' request from time to time. It's really fantastic program. I once again thank the organizers for arranging such a wonderful program, even the COVID pandemic situation. I'll appeal to all the participants and delegates, very part of the country. So be safe, be safe at home, and take the government measures, follow it properly, and we can come out with the COVID pandemic issues. Thank you so much.
Thank you so much, sir. Thank you for your valuable feedback. Participants, anyone else?
Hello, is it I'm audible, madam?
Yes, ma'am.
Hello, this is Vatsila from Bangalore Institute of Technology. I came to know very lately about this AICTE, but the program was well organized and systematically executed by Abhilasha Madam and the team. I'll take this opportunity to congratulate them, and information whatever is shared actually above our level of understanding. It means a high level information is given regarding the dynamics, either maybe the earthquake or maybe the dynamic loading, okay, and the dynamic analysis. For this, for giving this opportunity, I'll thank your management team and as well as Abhilasha Madam. Thank you, ma'am. Thank you very much. That's all.
Thank you so much, ma'am. Participants, anyone else to share your experiences? Pani sir.
Good afternoon, madam.
Good afternoon, sir.
This FDP, who conducted this FDP was completed successfully. So from this, so it was very helpful to me. All the outstanding. So I'm thankful to them for doing this talk. The management and managed this workshop. Thank you.
Thank you so much, sir. I think there is some network issue with sir. Participants, anyone else? Please share your experience. Okay, thank you so much, dear participants, for sharing your valuable feedbacks and experiences. Now, I welcome Dr. Abhilasha PS, Associate Professor, Department of Civil Engineering, Vidya Academy of Science and Technology, and co-coordinator of this Atal Faculty Development Program, to deliver the vote of thanks. Ma'am, please.
Honorable dignitaries, Principal Dr. Saji CB, Vice Principal and HOD MCA Dr. V.N. Krishnachandran, who is presiding this valedictory function, Dean Academics Dr. Sudha Balagopalan, Executive Director of Vidya International Charitable Trust, Mr. Suresh Lal, Administrative Director, VICT, Mr. P.N. Unirajan, retired IPS officer, heads of various departments, colleagues, dear students, and our Atal FDP participants and the session chairs. Namaste and good afternoon to one and all. On behalf of Vidya Academy of Science and Technology, Thrissur, and the organizing committee of FDP, I feel immense pleasure to take this opportunity to propose a vote of thanks to all those who have helped us to successfully complete this memorable 5 days online FDP program sponsored by ACT Training and Learning Academy. So first of all, I would like to thank Dr. E.J. James, Professor Emeritus and Director and Pro Vice Chancellor of Karna Institute of Science and Technology, Coimbatore, Tamil Nadu, who spent his valuable time to inaugurate the FDP on 6th December 2021. Next, I would like to thank all the 11 resource persons, that is Dr. Katta Venkataramana, Professor, NIT Karnataka, then Dr. KPM Namboodiripad, retired Professor, NIT Calicut, Dr. Ajit Chaurasia, Senior Principal Scientist, Center Building Research Institute, Roorkee, Dr. T.P. Somasundaran, retired Professor, NIT Calicut, Dr. Sajit A.S., Professor, NIT Calicut, Dr. Deepa Balakrishnan, Professor, School of Engineering, Cochin University of Science and Technology, Dr. Robin Davis, Professor from NIT Calicut, Kerala, Dr. Bharati Raj, Assistant Professor, NSS College of Engineering, Palakkad, Kerala, Dr. Kavita P.E., Associate Professor, Federal Institute of Science and Technology, Kerala, Dr. Smita K.K., Associate Professor, Tokich Institute of Science and Technology, Kerala, Dr. Robin Bhaskar, Senior Project Officer, National Center for Safety of Heritage Structures, IIT Madras, Dr. C. Jalal bin Shah, Professor and Head, MES College of Engineering, Kerala, Dr. Justin Joshi, Professor and Head, Civil Engineering Department, Vidya Academy of Science and Technology, Thrissur, for their valuable time and for the knowledge shared with us related with recent advances in earthquake engineering. And now I would like to thank all our Vidya International Charitable Trust members, especially Executive Director, Mr. Suresh Lal Sir, Administrative Director, Mr. Unirajan Sir, for all the support and facilities given to us. Thank you, sirs. Now, I would like to thank our principal, Dr. Sajid CB, who is always there with us, giving guidance and support. On behalf of FDP coordinating team, I would like to thank you, sir. Now, I would like to thank our Vice Principal, Dr. V.N. Krishnachandran, for presiding this function. Thank you so much, sir. Next, I would like to thank our Dean Academics, Dr. Sudha Balagopalan, for felicitating us and for the suggestions given. We'll surely take care of that, ma'am. Next, I would like to thank heads of all departments, teaching and non-teaching staff of Vidya, especially our technical support team, Mr. Shali, for all help rendered, and Mr. Shivdasan for facilitating this online arrangements. I also thank Mrs. Vijay Vinodhan of EC department for the design of brochure for submitting it to ACT Adel many months back. I also thank our student volunteers, Anjana Pianil and Anjali S. Nair for prayer, and Alfred George for the poster design, and the list is many more. Next, I would like to thank none other than the FDP coordinating team, that is Mrs. Nisha Verghese, Mrs. Adra P. Nair, then Anu Maria Antony, Ambili P., Kiran Babu A.R., and none other than HOD of Civil Engineering Department of our college, and also he is the chief coordinator, that is Dr. Justin Joseph, for all the support and help given. It is because of the dedication and hard work of each one of you, it made this FDP a beautiful one. Thank you, dear all, for the excellent team spirit. Now, I would like to thank the core team of our FDP, that is about 70 to 80 participants registered for this FDP from various parts of our nation and who joined FDP. I hope all of you could gain many things and empower yourself during these 5 days of Atal FDP. And I also thank you for your valuable feedback. And next and last, I would like to thank AACT Atal officials who accepted our proposal and helped us to organize this FDP on recent advances in earthquake engineering. Once again, I thank you, each and every one of you, from the bottom of my heart. Thank you all, and stay safe.
Thank you so much, Abhilasha ma'am. Actually, you were the backbone of this FDP. Without you, this program would have been a dream. Thank you so much, ma'am. Now, I request everyone to stay back for 5 minutes and switch on your video for a group photo.
Are we required? Idea?
Yes, ma'am.
Are we also required, or only
Yes,
the participants?
yes, of course, ma'am. Please, please.
Okay, thank you. Yeah, happy to be a part.
Let me also join, madam. Thank you.
Yes, ma'am. Yeah, Katta sir. Thank you so much, sir. Thank you.
Very well
happy
organized and yes.
Thank you, sir. Thank you.
That's a very pleasing feedback.
Yeah.
We value
Yes,
your
madam.
comment.
Yeah. Very well organized and yes.
Very happy to collaborate with you, sir. Thank you. Thank you so much.
We may need him further, isn't it? If our students are going to do something, we'll need your help, sir.
Certainly, madam. My pleasure. Yes.
We would like to model. In fact, I was talking to students of the first year here. Some vulnerabilities, if they can model, at least the common man will be able to see that these are the problems that are going to, these are problem areas in any kind of as-built structure. So they might be a little more careful, because when children talk, people listen. I've noticed that rather than
yes.
Is it over?
See you all.
Our smiles are slowly disappearing.
First time we could see participants now.
Is it over, Abhilasha?
Yes, ma'am. Yeah, photos have been taken. Yes.
Now we can.
Thank you, ma'am. Thank you, everyone. We'll give the feedback.
Our KBM sir was not at all smiling. What happened, sir?
Oh.
You weren't smiling at all. Yeah, this infectious smile is so beautiful.
I shall make amends by
Okay.
having a big Open
Open laughter. Yeah.
Thank you.
So
Thank
we'll
you.
conclude on that, isn't it? It's nice to see your
Yeah.
big laugh.
Thank you. Thank you.
Thank you, sir.
Thank you, sir. Thank you, Kevin, sir.
Thank you, Abhilasha. Thank you, Justin, everyone.
Thank you so much, sir.
Yeah, thank you, Justin and Abhilasha. You are the pride of our institution. Okay. Let's hope you continue to be that.
Okay, bye-bye. Thank you, ma'am. Thank you so much.
Okay, thank you all. Thank you very much.
Thanks to all.
Yeah, thank you, sir. Feedback link will be
Okay, then.
shared.
Yeah.
Okay, then. Bye-bye, sir.
Bye. Thank you.
Bye-bye all.
Please fill the feedback form and submit today itself. Okay. Those who want certificate, it is mandatory. So please don't forget to fill the feedback form and submit it, please. Link is shared now. It will be shared in WhatsApp group also. So once again, thank you all. Thank you.
Thank you, madam.
Thank you. Welcome, sir.